Good morning. Okay, I turned the music down for me because it was a bit loud. I'm going to get the link. Okay. So what have I been up to? I've been up to, doing some things with math in this project. Um, it's pretty interesting. So I have basically come across some interesting things uh, with my old implementation of Flowlenia, uh, including some mistakes that I made. But those mistakes actually turned into uh, successes. Um, those mistakes, what I went back and I found this big mistake that we were actually reading from uninitialized memory. Something wasn't zeroed, and so we were reading just zero, just a really large integer, all through an array. And so what I realized later is that once I fixed this problem, and I got us back to a correct implementation of Flowlenia, I realized, wow, it is incredibly boring in three-dimensional space. Which did make me sad at first because I it was kind of like my dream of like being able to see these creatures floating around and stuff. I thought that it would be so cool in 3D space. However, I implemented it and they just kind of look like blobs. It kind of takes, strangely enough, it takes the illusion of the 2D space, it looking like this little sort of cellular organism kind of going around, and it kind of takes that illusion away once you put it in 3D space, and now it just looks like a circle, um, which sucks. It does suck, but anyway, I was like, okay, but like, what if I look at this bug that I had and try to understand what makes it special, and try and harness it and make something better with it. And so that has been what I've been working on, and I have implemented some very interesting ideas. Okay, so what exactly have I been working on? Well, the interesting thing about Flowlenia is that it's all about mass conservation, right? We take the growth part of Lenia out, right? And we're saying, okay, we have the same amount of mass, right? We want to move it, right? And, we do that by basically, looking at a position and then finding destinations to the position from our surrounding parts of the grid, and then we're finding how far that the momentum, the velocity of that position to us is. What that looks like in math is scroll all the way down. Okay, so what that looks like in math, right, is that we have this and we start from the destination, right, for all of our grids, and then we're going to iterate around that, right, in a cube, but and it's not actually a cube, right, because we have these offset tables. I'll get into this in a sec. So we iterate around, right? And then this is what we are putting mass into. And so we calculate using this mu, which we compute beforehand. The mu is basically the distance, right? It's the f, which is the velocity, and then we're just for each position, it's basically you add the position plus the velocity, and then this gives the offset, right? And you're saying, okay, our starting position is this far away from that displaced position, right? And then that is the exact strength that we are going to accumulate into the destination. So I hope that you are seeing what I'm getting at here. So this this mu is what gets calculated here. It's literally just the x, y, and z for each position plus the f, which is the velocity times the time step, and then we clamp it between a certain range that's based on the dd and the sigma, right? It's dd minus sigma is this ma, and then that gives us the range for basically how far a particle, it's not really a particle, can move within a simulation step. Okay, so why am I explaining all of this? Well, it's kind of important for me to explain it to kind of understand where I ended up taking it and why mine differs from classic flow linear. What we're looking at here is not conserved mass, even though when you're looking at it, you may be saying it looks like relatively the same amount of mass, right, moving through. I didn't check that my mic was working. Okay, hey Costco. What is the resolution and scaling on native? Are you running Windows XP with GPU pass-through, or is it a VM? I don't have a virtual machine, no. This is my computer. I have a capture card. That's how I do it. I don't know what the resolution is. I think it's like, I can check. What is it? Oh, yeah. So it's 1280 by 768. That's the resolution. Anyway, so this is not mass is not being conserved here, even though it looks like our mass isn't growing, or that our growth isn't expanding. This is not like classic mass conservation. I can show in a little bit what that would look like, because my goal here moving forward is that I want to make these things modular so that you can press a button and then change it to a different style of simulation, because I've now, over the past few days, I've I have a bunch of different hyperparameters and styles that I have kind of found, that I've discovered, right? So this is not mass conservation. So if I can explain what's happening here, in flow linear, like I said, we do not apply the growth step. Instead, we take that h and then we put it into this variable called nabla u. And then we interpolate between nabla a and nabla u to get our f, which is our velocity, right? So that growth basically translates into how we are displacing the mass, rather than being growth, right? So why am I explaining all of this like it's some sort of video? I don't know, because I've come to an interesting understanding about how virtual ecosystems work, right? So we have the classic like Conway's game of life thing where it's like underpopulation, overpopulation, right? You've got a certain cell in a grid, and if it's surrounded by too much, then it dies out, and if it's not surrounded by enough, then it dies out. And then if it is a dead cell and it's surrounded by just the right amount of life, then it comes to life, right? So this is like the model that we base everything off of, right? We have this growth function, and that's where the growth function comes from, right? It's this understanding of if the neighborhood is too low, then we die out, or if it's too high, then we die out. But die out is more like decrease, like we will decrease the value, rather than growth, right? The growth happens right in the middle. And so this is very important when we're talking about when I say not conserving mass in that way. This has a growth step in it, which is why it's not classical flow linear. So it has a growth step inside of it. But it's important to note that just because something has growth and isn't conserving mass, that doesn't mean that visually that's what's going to be happening. Because when something grows in this sort of like virtual simulation, like I was just talking about, something else dies. So it is sort of like this, we do find this equilibrium a lot like we're looking at right now, where things are popping up and then something else dies out, right? It's my second time catching one of your live streams. Why am I not streaming on Twitch though? Because I started streaming on YouTube because I made videos on YouTube, right? So people like that watched my videos, right? It was just like a normal thing, right? Like back then I didn't really even like have like a Discord or anything to be like, hey, I'm going live or whatever. So that was kind of like why. People keep asking me to stream on Twitch, but it's like, I don't know. I don't like to split my audience up very much, you know what I mean? Like, I think that, I don't know. Everybody in one kind of chat is probably good, you know? It would also be like I would have to like buy like Restream or whatever to stream to both, or have like a good computer. I don't have a good computer to just stream on YouTube, you know? So it's really difficult for me to like, I would not be able to encode to both. Like I just don't have the ability to do that. Hey, what's up, y'all? How you doing? Long time no see. I hope that you're doing well. Not running a VM, then is it safe? Additional antivirus? I don't have antivirus, no, but I don't connect it to the internet. That's the best thing about this computer. Thank God I don't have the internet on it. No, I just code on it. I'm doing well. I'm doing well, Kiel. I hope that you're doing well with the graphics programming stuff. Anyway, what was I talking about? Oh yeah, I was talking about the growth function and the equilibrium and etc. etc. I want to find something cool here. I'm just pressing the random button. I have a random button that I just skipped something cool. The annoying thing is that I've been trying to get other parameters to work, like these params, but it does take a while to find something cool sometimes, which is kind of a bummer. But anyway, so I was talking about the equilibrium for the growth function. So just because we have growth does not mean that mass is going to explode and then there's going to be a field full of mass and it's going to be a blob and boring. No, every time something grows inside of our virtual kind of simulation, right? something else dies. So in a sense, it is conserving mass, right? But the idea of conserving mass and stuff is if you want it to be physically correct, you know, like if you're making a physics simulation or you're making a fluid simulation or something like that, right? Then you want to properly conserve mass and not have this sort of growth happening. But I think that it just results in kind of boring patterns to be honest with you, most of the time. I find the kind of the patterns that this makes to be a lot more intriguing than the ones that don't have a growth function. So that's what I discovered. So I put the growth function back in. And I not only put the growth function back in, but I started to really think about how the how our velocity is calculated, and I made this which is a very interesting kind of way about going about this. So this is our grid after our growth function, and then this is the average of the grid over a bunch of different frames. I kind of just want to put it back to like better params so that I can explain what I'm talking about better. So basically what this is doing, right, is the alpha is what controls how much of nabla u we get and how much of nabla a. Once again, nabla u is the growth function, and nabla a would be the sum before, right? The sum from the step previous, right? And so the idea is that we are trying to estimate just how far we're going to be going. And so that's what this is doing. So my idea was to basically get the distance between that we did grow from the average, you know, over the past few simulation steps to determine, you know, how fast we're going to go. And so that's where this starts, right? So that's the first thing that I did. So here I center them around 0 because later I implemented an oscillator and I was really having trouble getting them to be even, right? So there's all of that. So that's like the back end of what's happened now is that, like, so I have this variable that sees how far we are from the moving average of the grid, and if we are changing a lot, then we obviously are going to have more force, right? And that's the F. Now I don't just stop there though, and how I displace the mass is completely different than normal flow linear as well now. And there's two reasons why. One reason why is that I think normal flow linear is probably good in 2D because you can be like less efficient, right? Because of, you know, you having like, you know, NumPy and all of that efficient rolling stuff. Unfortunately, in 3D and on Windows XP, it's kind of difficult. What am I up to? I'm up to this. I'm up to my neck in water, drowning in math. Hey, what's up, Harold? How is my relationship? Are you past Windows stuff? And now doing the... What is the real deal? What does the real deal mean? What does the real deal mean? What would the real deal be? Like making my own apps. Like, are you done with Win32 API, or are you building your own operating system yet? I'm doing math. I was just talking about the math actually. So I don't just stop there with the moving average for the grid itself, because I realized that the very way that flow linear tries to move its mass was, one, uninteresting in terms of... I like this stuff not because I'm trying to estimate real life, but because I think art is cool, and I think art with math is cool. Like, this is fucking sick to me. So I just think that if, doing all of this physics accurate math just isn't very interesting in terms of like making shit that looks cool. And so what I did is I said, okay, we're just going to throw all that out the window and instead have a moving average for our F, which is our velocity, and we are going to calculate trajectory based on that. So the way the traditional flow linear thing is, right, is that we basically have our destination, right? We're looping through, and it's backwards, right? So we start with our destination, right? And then we're going to go in a circle around our destination, and we're gonna find basically mass that is moving to our destination, or mass that is moving, if seeing how far we are from how far the mass is moving, and then based on that value we're going to add, right? And so this loop is 0 or 1. This would be like to a large number that is just a kernel around the cell grid. And so that's how typical flow linear does it, right? Is you have your destination, right? Then you're going to look around it to see mass that has an offset, and then you're finding the difference between the destination and this, and then you are using that to go into it, right? So you're moving mass into that destination, okay? However, that's really fucking expensive in 3D, right? Because if you want to have basically, a cube, of a radius of 2, right? This becomes an incredibly large number to be doing all of this math with, let alone you have 3 to 4 channels as well. It's absurd. Oh, I'm not. How are you? How is your relationship with programming? I've been doing good. Bit early? Yeah, I've been trying to fix my sleep schedule, so I got up early. USA just won a gold medal in hockey? That's awesome. I'm a huge hockey player myself. I'm just kidding. I used to really, pretend to like the Winter Olympics, I thought that it was, cool to, everybody used to be all into the Summer Olympics, and I was just yeah, I like the winter, I used to pretend to be into curling. I was talking about this the other day with my dad, is that I was never actually into curling. I just like the idea of being into curling. I have that with a lot of sports, where it's I like the idea, right? But it's never I never sit down and I'm oh, curling, I think it's probably cool. It sounds cool to me. It's the same thing with baseball, we would sit down in college and watch the game or whatever, watch the Yankees, and I would just really pretend, Yeah, whatever. Uh, anyway, go USA, go USA. Anyway, so what I discovered, right, was that I had this bug, right, where this was iterating in a cube, right? So this went a cube around the destination, right, and accumulated mass into the destination. What I discovered was I had this bug that I didn't realize where only index 1 was happening, where we were only accumulating from the destination into the destination, from it into itself. Um, and so I fixed this bug, and then I started, iterating over everything properly, and I realized that, wow, that actually is so much more boring, actually, like the visual result of it. And I'm not really like 100% sure why, but as you can see, based on, the patterns that we've been seeing in the simulation, mass kind of moves on its own, right? We don't necessarily have to displace it as long as we are meeting certain conditions for it to move in interesting ways, right? Um, so I simply got rid of it, right? And I looked at, how could I basically replace this, because I don't want to just like not have reintegration, not have mass, transportation at all. If it's just the destination into the source, there's nothing that we're doing, basically. It's like there's like no point in having all of this Sobel convolution, none of it, right? And so I was like, okay, well, what would be the interesting version of it, right? And the interesting version in my idea was to say, we have a velocity. Each cell has a velocity, which is f, that we talked about. But then we're going to have a moving average for that velocity, right? That gives basically the trajectory over, a bunch of different simulation steps. Okay. And when we are going to, basically move our mass, right? We're going to move it to that velocity, and we are going to move it by the magnitude of how aligned we are with our immediate velocity f. So how I move mass is exactly by the magnitude of how aligned v is with f. And so that's kind of the that's exactly what we're looking at right now. And so that's why the name of the stream is temporal averaging, because that's what I called it. We have multiple moving averages in the simulation that are controlling how we displace mass, which is completely different than physics. And it's that the reason is, I think physics is for fucking boring. No, I think it's cool. But I do think that it would be cooler if we stopped, trying to make everything a goddamn fluid simulation. Anyway, you can play with the parameters a lot and get some interesting stuff. So what I'm going to be doing today is cleaning things up and moving all of these hyperparameters into the UI so that we can toy with them, rather than me having to, the complexity itself is boring. I'm not sure about that. I think I don't think it has anything to do with the complexity. So the linear part is done. Yeah, I mean, it's been done for like, couple of weeks at least. But I don't know. I think my what I love about Lenia is how cool it looks, right? And so, sitting here with, trying to explore the parameter space in 3D is really difficult. And so, I don't know. Yeah, I mean, the Flow Lenia stuff has been done. I've just been working on optimizing it for the past long time. Like week or so, probably. Yo, what's up, Egg? Okay, big man. I don't know. I mean, the Lenia stuff was definitely finished 2 weeks ago. Maybe my concept of time is weird, but the Flow Lenia stuff was definitely like I was still doing it last week, but the last like 3-4 streams I've done is pretty much maybe 3 streams actually. It's kind of like just trying to optimize stuff. Anyway, it is difficult with the hyperparameters to get stuff that is interesting all of the time now. I think that overall it has really interesting capabilities, but it is very hard to control those capabilities. So that's why I want to move the parameters into the UI. So that's what we're going to be doing. Also, we have this dampening for the velocity every time we change it. But this is what I was talking about, right? Is we have a moving average for the velocity. And then this is down here how we use it, right? And so we use it just like basically here. What we would be doing is we're checking around our destination for finding mass that's moving into it. Instead of that, I go by I go outward, so I do the opposite way, right? So I go from a cell, I look at its velocity, and then I go to that velocity and then distribute it within a cube around it like this. And the effect of that is, it's much more efficient because I don't have to nested loop here anymore. It's not only efficient, but it also creates some interesting stuff. So yeah, there's that. So I need to move all of this into the UI. So that's what I'm going to be doing today. Also, I backed up the project, and what I'm going to be doing is just deleting a lot of stuff and cleaning stuff up because honestly, oh yeah, I forgot to mention also the rendering. The reason why the rendering is so fast now is because I completely have done some, honestly, some of the most crazy, disgusting code I've ever written, right? So we have 4 threads right now. 2 of them are doing the simulation and 2 of them are doing the rendering. And they happen on top of each other. And it works barely. Once again, this is on Windows XP on an old computer, so it is very hard to do it. It's very, very, very difficult, but it happens. And I think it's about 30 FPS depending on the configuration, which I'm pretty happy about. And to prove what the statistics are looking like in terms of the different parts, right? And so I set up this kind of debug sort of printout, right, that shows us the entire frame. This is thread 1 and that's thread 2, right? And so our reintegration, since my refactor and this math that I'm talking about, making it more efficient, is now 0.0063, which if you remember, this used to be 0.02, which is an incredibly, an incredible amount. Now, of course, this is depending on the configuration, right? This sometimes still goes to 0.015, right? But it has considerably gone down because of my efforts in streamlining the math. What is the specs? The specs is, I think I replaced the CPU like a while ago, but it's nothing good. It is a AMD FX. So the 4300. So this is actually not that bad of a CPU. It's really also the GPU that's kind of the problem. The GPU is like, I think it's a Radeon 200, 240, something like that. Yo, what's up, Sleepy? What is up? It's not like the worst computer ever, but I mean, certainly doing what I'm doing on it is, kind of pushing it to its limits for sure. Yeah, 4 gigs of RAM. This used to be a lot. This was a nice computer back in the day. But yeah. Anyway, so this is what the math is like, and so if anybody asks me later, what have I been working on, I'm just gonna tell them to go back to this part where I, literally explain the entire math of the simulation. How much memory? Like in terms of, I don't know. I literally don't know. I don't malloc anything. It's all stack allocated, so I would not even know. I mean, I use FFTWF malloc, but yeah, so I have no clue. I would have no clue. Probably a lot, to be honest, but it's also, I don't know. It's probably, it's not like, so it's this. These are pretty much all of the buffers, which it looks like a lot, but it's not like an insane amount. So this is max channels is 3, and so for how many cells we have, right? So it's like 32 by 32 by 32. So you can do the math on that yourself. But that's pretty much all the buffers, and then these are our FFT buffers. So yeah, that's pretty much all of the memory in the project. And then there's the kernels too, I suppose. Max channels is 3. No, it's 3, yeah. Because there's no way we can do 4 on this computer. I realized that as soon as I pushed it to 4, and as soon as I push the grid past 32, it's not happening. There's like literally no way I can make that happen. No way. So it's unfortunate, but I mean, to be honest, in 2D, I pretty much capped out at 3 in terms of channels as well. So yeah. Anyway, so I'm almost using my whole stack. I mean, I don't know. I haven't really. Yeah, I mean, I haven't ran into like literally any issues. So, but I guess that is possible. I don't really know what the exact value is, but if I have to allocate stuff later, then I will. But yeah, also a lot of these probably can be put into I feel like Knobbly U also we could put it flattened out like this, because apparently this is faster according to Google. But you know me, I haven't read fucking CSAPP, so I don't know what I'm talking about. But yeah, we can try that. Let's just call it NU, right? Yeah. Sorry, I don't know why I'm so nervous today. I get this way when I don't stream for like a few days. I just get kind of, no, I already have NA, do I? No, I don't. Even if you were to push the limits at most, what channels would we get anyway? So if I was to push the limits to have more channels than 3, we could technically check it right now, what it would be like, if you want to. But yeah, it gets like really, really sketchy because it's like exponential past that, how difficult it is. Let me find where I have the define at. Yeah, so let's just push it to 5 and see, just for, you know, argument. But because of just the amount of convolution, iteration, everything is by channel, right? So literally every iteration that we do through the entire grid, we have to do it for each channel. You see what I mean? So it's pretty hard to push it, but also like having 4 channels, 5 channels versus having like 3, really there's no benefit. There's no benefit in terms of visual. By the way, the channels are the different colors that you're seeing, right? So like the blue, the red, the green, the this, the that. Yeah, so okay, so that's what the problem is. So yeah, so it isn't even if we wanted to push it in terms of like processing power, we literally can't. Because DirectX will literally just run out of memory. So there's your answer. We literally can't. I'm not allowed to. That's not my fault. That's just me pushing the limits to the absolute, you know, limit here, where I literally can't allocate any more memory in DirectX. In fact, we've run into that through the entire project, me having to slim everything down in memory. Yeah, we're already at the limit, pretty much. Yeah. And it's not even that much. I could probably slim it down a little bit, but it's like, I don't know. So the thing is, we have a front buffer and a back buffer, right? And so if we got rid of the front buffer, back buffer thing, which we don't necessarily need it anymore, the front buffer, back buffer, because, or no, we do. Because to be as fast as possible, I multi-thread even the upload. This is a multi-threaded thing, or a threaded thing. So while we're rendering, I'm doing this. If I don't do it this way, then we get stuttering, because this is an expensive mem copy. And so if I did this, basically, between frames, right? So like, we do a frame, then we upload, and then not have the front buffer, back buffer thing, then we would have stuttering. So what I had to do was thread this so that we upload to the back buffer, while we're rendering, because this function cannot be called in between frames. It's too slow. It's literally too slow to get to 30 FPS with this. So that's out of the picture. So I blame my ass for wanting to do this shit on Windows XP. Blame me. Okay, so Nabla A and Nabla U. We can totally refactor this. It's very easy, right? To the same convention as we have the other Vec3 stuff. And I don't know if this is faster, having no struct here, but according to the internet, it is. Did you hear that Obama said that there's aliens? My mom was talking about that. God, it's funny, dude. Like, there's no alien files. There's no alien files, dude. There is no alien files. I promise you. I promise you there's no alien files. I know we really want there to be aliens, but I'm telling you right now, there's no aliens. What are you talking about? What are you talking about? Did I... Oh. That sucks that there's no aliens? Okay, it looks like this works. I'm telling you, man, I just don't... I feel like if we knew about aliens, we would know about it. There's no... You know what I mean? Like, there's no way that the government could keep that a secret. You know? Like, there would be an Edward Snowden, like, situation immediately. There's no way that we would not know, I feel like. You know? Like, that's aliens, bro. Like, no one's keeping that a secret. There's just no way. When I saw E.T. when I was a kid, I cried. I think I did. Who doesn't cry at E.T. though? I feel like that's just a crying movie. No? You gotta be like some sort of psychopath to not cry at E.T. Well, that's neat. Happens to the best of us. Dude, I'm telling you, bro, like, crying at AT is not... It's not. I never watched it. Is it good? Yeah, it's really good. I haven't seen it in like a billion years. Compared to Wall-E? Oh, I mean, I love Wall-E too. I love Wall-E too. I guess E.T. is just more of a classic, you know? I think that does take Sobel down actually a bunch, actually. Actually a bunch, actually. Yeah, that's pretty fast, actually. Nah, sometimes it isn't. Can I make the grid size bigger? Absolutely not. Absolutely not. Absolutely not. You're gonna run into the same same allocation issues. Not only that, but it's gonna run like absolute dog water. I don't even think that we can go with 38. I don't think that it's possible for the allocation. Is it? Oh, it is. It's just gonna run a lot slower. But 38 by 32. 38 by 38 by 32 is possible, like this is. But it's like, do you see the frame rate difference is kind of insanely worse. Like, it's like 15 FPS. 4 channels, not possible. 4 channels is literally like, that's another 1/4 of the allocation resources. I mean, maybe it's possible. 4 might be. But there's literally no benefit to it in terms of like visuals. 3 channels is pretty much the average, or the main thing. Like 4 channels doesn't really give you anything. Okay, well, we do have 4 channels apparently, so this has 4 channels. I don't even know what the color of the last channel is, but as you can see, it's pretty slow. We can make it like white. I don't see it. Might be that nothing's hooked up to it. So let's hook this up to it, I guess. Let's see if we can... There it is. So that's the 4th channel. I don't see it. Well, it's white, but there's actually like a yellow light, so that's why it's like brownish. Yeah, so that's the 4th channel. It's not incredibly slow, but the whole point of having different channels is to have them interact with one another, because we obviously have kernels that are coming from a certain channel and then exporting to another channel, right? So it's based off of this channel, and then it goes to this other channel. So that's the whole point of it. Really, with 4, there isn't really a benefit to it. Also, like, I don't know, like, if you look at the people who made Flowlinia, for example, which is what this is based off of, they pretty much just stick to 1 channel, pretty much. At least they're examples. So I'm just going to delete like a billion things. I think in this case especially, like, more definitely is not better. I think like making the math more, you know, more streamlined, and like exploring the parameters better is probably going to lead to better results, rather than just like upping the amount of things. I even think we have too many kernels on average. We have 10 kernels at you know, our maximum. That's a lot of kernels. But 10 kernels, 30 FPS is something I'm pretty proud of. Also, I am not doing the complex multiplication anymore, in Simmed because we did it wrong. So I'm just doing it regularly now because apparently it was slightly wrong and I realized that later. So there's that. Let's see if there's anything else I can do really quick. I'm gonna put all of this stuff now into like different sections and clean it up. So yeah, so we can get rid of all of this, but the fact that U is like this, I feel like I could probably do this better. I'd have to think about it. Can get rid of this. I do think I'm going to probably be done with this project soon, though. I mean, yeah, like, I don't, like, see there being, like, a big, like, you know, now that I had, like, this big kind of breakthrough with the math and, like, made it my own and stuff, like, it's, like, I don't know. I don't see a lot of point in, like, you know, continually making it more and more, you know, optimized and stuff. I'd rather kind of just like keep going and work on something else. If I want to make this more... no, yeah, it has to be... No, I could put it on, yeah, and then get rid of this. I could just put it on thread data instead. Then again, that would be a pointer dereference, but yeah. So it's either biting the pointer dereference or having this bad cache layout. I'm kind of too dumb to know which would be worse, but I'm assuming that I don't know. People keep on telling me how bad this is for cache, but I don't know if it's worse than a pointer dereference. We can try it. Just straight up put it on here. Oh, whoops. Put it on the thread data. I've also, yeah, I've been watching some fucked up movies lately. Like just like horror movies, like Saw. Dude, that movie, those movies are like so feel bad, man. Like I'm like a big horror guy, a big like, you know, like gore guy, like, you know, like all these weird, you know, gore Japanese films and stuff, and like, so I'm like pretty desensitized to it. But dude, like those movies are like so feel bad, like they literally just like make you feel bad. The movie, like, I don't know. It's like such an American thing, I think, to like literally take enjoyment at other people's suffering, you know? Like I like gore and you know, and like horror and all that, but it's like it's not entertaining to watch somebody like literally suffer, you know? I thought I might as well watch it because I've never, you know, seen it before, but yeah. So yeah, we'd be going into TT C. Oh fuck. No. Yeah. Never mind. Don't do that. Because then it's still going to have to be nested, or at least have a struct inside of it that's grid. Because it's per grid. Yeah, I forgot about that. That's my bad. Yeah. That is kind of a bummer. I guess you could technically do like 0 and etc., but it's like, it's kind of over engineered, I guess. Yeah, never mind. We'll just do this instead. Okay. Okay. Yeah, so I think I'm gonna look at the code for this and then try and figure it out, because that's our last bottleneck, is actually the first code that we wrote, right? The regular FFT stuff, and that's the exact stuff where we go by U. So we go by kernel. But we don't need to be going by channel. Technically, we could just be U by kernel. Yeah, we could make growth sum a separate struct with just just the UFFT stuff to the amount of kernels. Yeah. That would probably be faster. Let's think about it though before I commit to it. Yeah, instead of going to C1, because C doesn't matter, literally just go into here. Yeah. Yeah, we'd have to make a separate struct here. There. Yeah, like that. I don't know what I'm gonna work on next. I think, I don't know. It's hard. I think I might like do, I don't know. I've been like working through CSAPP, and I want to do some I don't know. I kind of want to like emulate maybe like an old console or something. I think that that might be fun. Like maybe if I like make a PS2 emulator or something, because I have a PS2 and I can like reverse engineer it, that might be fun. People were also saying like I would love to see you do that, so yeah, like that. Okay. I mean, technically that should just work. I mean, I don't really know. The reason this is a good one to start on is because it has 3 channels, and so it's good to like limit test our stuff on. I feel like that's okay. Yeah, maybe not. The thing is, it's kind of dependent on the amount of kernels. So at 6 kernels, we're just under 200. Now let me see what it's like. How many kernels is this? This is 10. If I get one with 6, we can really test. Yeah. So at 6, it's pretty similar. It's pretty dependent on the amount of kernels. Yeah, I'm gonna keep it. I don't think it's doing us harm. I wonder how much this pointer dereferences are hurting us. Also here, we're using this val instead of the grid. Yeah, so use the grid, because grid has a better layout. I don't think we're very often doing asymptotic though, so probably has nothing to do with anything. Trying to see if there's any way that I can like iterate this in a much cleaner, like faster way, you know? Like yeah, there's kind of no way. I think it's faster to do it actually in 2 loops like this, because if you iterate anywhere per channel in this, then you're wasting stuff, because kernels actually only go to like 2 different channels. But the thing is, you have to basically add into H for each U that corresponds with a certain channel. Yeah. But yeah, there's no way. I was trying to see if I can move this inside of here. I just don't think that I can. There's just kind of no way for me to. I wonder how much this is hurting us. Probably not a lot, no. Yeah, it's probably not a lot at all. It's probably, we're literally just probably paying the cost of FFTW with this. Yeah. It's probably just literally that. Like, it's hard for us to really see, but I could set up a timer for it just to absolutely make sure. That's what I'll do. I'll profile it and see. I just want to get the boilerplate for it, and I just want to profile the yeah, so let's just profile this. I need to get the boilerplate to exit out too, because it's so annoying to write it every time. I think I just called it cdiff actually. Okay. Did I name it wrong? No. What? Grid is not a member of cell FFT. Oh. Unresolved symbol. Oh. It's supposed to be C. So let's see how much it is. Oh, wow. Wow. Yeah, that's nothing, actually. That is nothing. That is nothing. That's crazy. That is really surprising, actually. That is really surprising. Okay, so let's move the profiling out here to get the whole initial step. Because I want to see... So this is the first step, which is... this is the first step, which is not multi-threaded. This is the FFT stuff. Okay, so this is a bit more. It's actually like 2 times the amount, which makes sense because there's another set of transpositions happening and that. But you're still... Yeah. 0086. It's actually a good amount. It's actually pretty interesting. So we're actually... Here is probably... So all of this is just our initialization for each simulation step. Just basically like zeroing stuff and transposing it into the right amount. And all of that happens is... It takes actually a bit of time. Like 3.7 doesn't seem like a lot, but you know, it actually is kind of a bit of time. But I guess it's necessary. Like, this is absolutely necessary. And zeroing the sum is also necessary, I think. Yeah. And the transposition is necessary. Yeah. Can't do anything about that. And then these, obviously. Yeah. Can't do anything about that until we, you know, multi-thread FFT, which obviously is going to be hard considering we already tried to compile FFTW with multi-threading flags, but then it failed. Yo, what's up, Bazix? I'm from New York, but I don't live there anymore. I live in like the southern East Coast of the United States. Not really out of my own choice, but so that means that also, we should have probably... Yeah, that's probably something that we should have done. We should be running this test with 6 channels, because that's what we did our other profiling with. So 6 kernels. So it looks like this one only has 2 channels, so it's probably not like the best thing, but so it appears like, surprisingly, the bottleneck isn't actually the FFTs. The bottleneck seems to be this. Hey, what's up, Sauce? I almost wonder if it's this. How about this? First thing here, let's get rid of this. Let's get rid of this. I doubt that, you know, branch prediction and everything, right? I doubt that that matters. But I wonder if it's actually this bell function. And if we should just make a lookup table for this. I'd be interested to see how much is exactly that bell function. So that's what I'm going to profile next. But that's what I'm guessing right now. That's what just clicked in my head. That actually the last time I made a Linea implementation, I did a lookup table for the bell function because of how slow it is, because it's EXP, right? So this is with 6 kernels. That's 70. Right, so these are both threads, right? So that's actually a lot. Like, that's pretty much half. Right? And so the makeup right now is like 0.00 like 6 is the initialization and the stuff that we can't change at all, and then 0.007 is this, and then the rest of it is this, is us literally just doing the clamp for every cell. So yeah, it looks like we should make a lookup table for the bell function. I kind of forget how to do this, but we can do it. The important thing is that we would have to define like ranges, right? So M would be 0 to... We'll like do 0 to 1. Also, this should all be floats. We only work with floats, so I don't know why I made it doubles. Let's actually test it with this. Oh wow. Maybe not. We aren't testing with 6 kernels. Okay, yeah. So now, yeah. Okay, so that's enough to convince me that we need to do a lookup table for it. So the lookup table needs M and S. And the value of this. So let's just think about this, right? So we could do, let's just for simplicity's sake say that it's this. Right? Because U will always be between 0 and 1. We're just going to assume for now that M and S will always be. Though they may not be at some point, but let's just, for simplicity's sake, do this. Now, I don't think that there's a point in actually flattening it out, but maybe I'm wrong. Maybe you do want to flatten it. Yeah, let's flatten it, because yeah. So it's just 256 times 256 times 256. Okay, so let's do that. Okay. Okay. So we're just literally going to yeah, actually, so I may be one off in my brain here. Hold on, like, yeah, so you want to multiply times 255, but then iterate to, yeah, so, yeah. Yeah, I'm not crazy, I'm not crazy. I'm not crazy, you're crazy. I saw a quote from Saw 7 where he's like, "You're crazy. I knew it from the moment I met you. You're crazy." Oh man, the way he delivers that line is so funny, man. Oh, that's a funny scene. It's like this FBI agent is like, "You're crazy. At the moment I met you, you're crazy." Yeah. Let's just literally do that then. Sorry, I'm feeling a little woozy here. I had one of these things where, so I have trouble like sleeping. Like I have like bouts of insomnia because of my mood issues or whatever. And when I do that, I have to take Benadryl to sleep, and like, dude, I like sometimes I take it and I wake up on days like this and I just feel so weird. How many leak code problems did I solve? 0. 0. I hate leak code. Um. No. Don't be dumb. Don't be dumb. Don't be dumb. Is it 255 or 256? Lock in? It's gotta be 256. Yeah. No doubt. Yeah, we'll go like that. Or do you want? Hold on. Yeah, you want do you want you to be? Trying to think about the stride here. What is your advice for me to improve without leak code? Just like make projects and programs, you know? Like, I don't know. Make something that's like, that you think is sick. Like, I don't know what type of programming you want to do, but like, you know, whatever made you want to start programming, then like make something related to that, you know? Like for me, that was, you know, it was like Minesweeper when I was a kid. Because my friends and I would be in class and we would play like Minesweeper because we were bored or whatever. And so I programmed Minesweeper. So shit like that. And then later, you know, I like wanted to make like weird 3D graphics stuff. And so I, you know, was like, okay, how do I make weird 3D graphics stuff, you know? And so then I did that, you know? Or if like none of that speaks to you, then like read a book, you know? There's lots of good programming books, you know? So one of those things for sure. I definitely would, I don't know. I think the whole idea of like programming is like as like this white collar job that you have to do like leak code for and shit. It's like programming should never have become a white collar job, you know? It's about like craftsmanship and shit. It's not like being a lawyer, you know? I'm wondering if you should be the longest stride here is what I'm trying to figure out. That's why. I'm thinking like M and S don't vary a lot, so they should probably be at the end, right? Or no? Yeah, it's the other way around. I'm being dumb. I'm being so dumb. Yeah. So let's just do that. Yeah. Don't even think about it too hard. If U is 1... Yeah. Don't even think about it. Are you ever gonna make tutorials for Conway's Game of Life? And self-explaining things, maybe the math? Yeah, so I did talk a lot at the beginning of the stream about like basically the way I made the math for this project. Like I've kind of done my own sort of take on flow linear now with like moving averages for velocity and stuff like that, so you can definitely check that out if you are interested in it. But yeah, I probably will like the chess engine video, but not as long. I'm gonna make a video about it. So you're saying that when I need the information I take time project? Yeah, exactly. I mean, unless so if you want to like do leak code because you want to like work for Google or some shit like that, then like you can do leak code. You know, it depends on what you want, right? So for me, I even if Google like offered me a job tomorrow, I would not take it because I don't want to work for a company like that, you know, doesn't care about me. So that's just for me personally, but it depends like what you want, you know. Man, I see you're going through with all this. Finish the final run through. Piano show. Oh, thanks, thank you, thanks, Tools. I hope the piano show went good. I didn't know that you played piano, or maybe you were watching. That's awesome. Um, okay, I think I'm doing this correctly. Uh, fuck, cool. I wanna. Yeah. So, I mean, exactly. So don't do. Yeah. I mean, if you're that type of person, then don't do. You know, don't do lead code. You know, it's that simple. But also like be wary, I guess, of like um I don't know, like just just like do whatever you enjoy and stuff like that, but also pay attention to other people's code that you read as well. Like pay attention and get good at reading code. That's what I'd recommend. Like get good at reading other people's code and learning from other people's code, because it's going to teach you a lot of things, you know. Like it took me a long time to like understand like C macros and when to use them, and like the cool things you can do with a billion other things in the language, just because I suck at reading code. That's kind of like my weak point. Leak code gets fun if you do it enough. Yeah, I guess. I just don't really see the point in it. Like, most of the stuff that I've seen from like leak code is like, it's none of the shit that would help me in like making this sort of stuff. You know what I mean? So it's like testing a whole other different thing. It feels like doing chess puzzles, Like, I don't think chess puzzles make you better at chess. It's the same sort of thing. But then again, I mean, I've never like, committed to doing it. So what am I doing here? I'm yeah, so we want to yeah, no doubt. I do it for the white collar. Yeah, if I got a job at like a white collar company, I would like not be happy. Social's book, yeah, it's a good book. I've never read it myself, but everybody says that it's an awesome book. Oh, that's the annoying thing, is that now I need it externed. Oh, this introduces a lot of issues actually. Well, not a lot of issues. I mean, I hope that this works, hopefully. I think I'm off. I feel like I'm really dumb all of a sudden. Hold on. Yeah. I think I'm gonna go out of bounds here by 1, and that's like a problem. That's a problem. I mean, like, why? Let's just do it the simple way, and just like straight up do the same exact thing that we just did. I don't know why I'm complicating this so much. Yeah, I think this is fine. I mean, yeah. Just wrap everything like this. Wait, hold on a second. These, oh, yeah, so this is what it is. There we go. Okay, that's why I was confused. And you have to cast this to an int. Okay. I don't know why it took me so long to figure that out, but yeah, there we go. That's awesome. That's awesome. Yeah, playing piano in front of people is so very difficult. Yeah, I went to music school myself, but for composition. But yeah, it's not easy. It's a lot. It's even harder than it looks. So yeah, I totally understand it. Yeah. Well, good luck. That seems like a lot of fun. That does seem like a lot of fun. Alright, I'm just going to drop this in now. Stop. Please stop. Okay. That's that. I know the last time that I did this, I actually interpolated between two. So I took this one, and then I took the seal one. With you know. But I don't know if that's important, you know? I don't really know. But yeah, whatever. Yeah, maybe we should do that. I don't really know. Whatever. Let's just put it in the header and then like just make sure to initialize it, and that's gonna be it. What did I just call this? Okay, I called it that, but it's not coming up because IntelliSense is mad at me because I definitely made an error. Oh. That's true. I did do that. Okay. Let's see the output now with 6 kernels. That's what we're testing. Okay. So that brought us down from 70 to 50 at max. So that's a pretty big thing. That's a pretty big performance increase. Now, it is an approximation, right? So if we find later that that's a problem, then we can, you know, move that from a less lookup table-y thing and more to be like linearly interpolating between two values. Like what I did last time was I basically floored it, and then I got the seal, and then I, you know, averaged them together basically. But I don't know if it's really necessary. Yeah, with 8 kernels being at about 200 is pretty solid for us right now. Yo, what's up, Switzerland? How are you doing? Yeah, we can get rid of a lot of this code is what I'm doing right now because I have a backup of the project, so there's really no need for me to like clog up the code base right now. So we can put this back. I'm doing well. I just been working on this pretty much. I've not been doing much otherwise. Just watching some horror movies lately. Kind of just like out of boredom, I guess. Now, there isn't much that I can do about this clamp. This clamp has to happen. Technically, what we could do is we could actually defer this clamp until later. I've been thinking about this. Like, I think I already actually do clamp at the end, right? I do clamp. I don't know how this would change things, but we can definitely think about it. I do clamp. Where's the code? I do clamp here, right? Do I not? Yeah, I do. I clamp this, which is our final, between 0 and 1. So I feel like, to be honest, we should just do that there. And instead of clamping here, because clamping is, it isn't the, you know, everyone that does like modern computer science is probably going to be like, you know, that's nothing. It's, you know, you're just clamping between two values, but it's like, I am on Windows XP, right? And so the soft clip would still have to be here, or you could move it to the end, but yeah. Yeah, the soft clip would still have to be here. But we aren't typically soft clipping anyway, so anyway, that should be a increase in the size. The divide has to happen here, unfortunately. It just does, for reasons. We just have to normalize it due to due to the whole FFT thing, so not much I can do about that. Okay, so there's that. Okay. So that's basically everything I wanted to do. Next, I guess, what we're gonna do is move some of this stuff into modes. So I want to make different modes for certain things. For now, we could just have this on border, actually, right? So I was doing a lot of testing here with our different things for Sobel convolution, right? This is a wrapping border versus having a wall border, and you just get different patterns based on what you have here. And so I actually already have an enum here that does this, but that just has a generic border, but I want to make it separate, right? So I want to have a border for our, let me know also if the music is too loud. I think it's okay. I want to have a border for the Sobel border, right? So we'll have it as wall right now just to test it. I wonder if the compiler makes this easy for us, or if we have to do something else, but whatever. So torus, if you don't know, is basically just a wrapping border. Not exactly, but you know. I think honestly we could design, actually, you know what, let's sit here for a second and think about if we want to make a wall border thing and how I would design such a thing. Yeah. So instead of just continuing, do I want to do a switch case here? Would that be faster? So this is border none because we literally just continue. If we find that we're off of the grid, instead of that, what I want to do for wall is I want to do it twice. I mean, I want to move this to here. So that will go like this, right? And then we'll see we'll do all of these in their separate conditions. Then IX equals X, right? Which is just like our center, right? So that's what we're gonna do. So basically what this is doing, why is this? So basically what this is doing is if we're off of the grid, we're basically, you know, just sampling from the center instead. Yeah, there we go. So that's neat. Okay, so that's what we're gonna do. We want to do that for the other Sobel as well. And this is cool because now I won't have to like keep recompiling to test this stuff out. We can add like a button that switches between them. Oh, my bad. I did remember it for one of them, and then I forgot for the other ones. I've never seen what this border type looks like. But okay, so this is wall. It looks pretty neat. So torus borders with Sobel convolution actually sometimes you would think that a continuous like wrapping around would make things less noisy, but it actually introduces a lot of noise because you don't really have like anything to anchor to. So I think a wall border typically, like, you get really cool patterns like this where it's like, you know, this is cool. I like just hanging out in them. I think that that's like so sick. It's so cool that you can get stable life with 10 kernels like this. Like, we have 10 kernels right now, which is crazy. Like, a very high amount, of course. Okay, anyway, that was cool. That was cool. Okay, so here is the other border that I was talking about. That can probably stay the same. Yeah, we should probably clean some of this stuff up. This sum, I was basically doing the, actually, hold on a second. Yeah, I took this out of it. I don't know if I should have. I should probably make this an option too. Should make all of this optional for like if we are temporally accumulating or not, like which, like obviously GA will always be, but the sum doesn't have to be temporally accumulated technically. I guess I could just like literally have different TAs for each thing. Like this could be for the TA for the sum, and then this is for the grid TA. Yeah. Let's make them different parameters, I guess. GTA. Yeah, let's make it GTA and STA, I guess. Okay. Oh yeah, I got a new chair. This is my birthday present from my parents, was this chair. They were like, "We know how much you sit down." So that was pretty sweet of them. Yeah, so that's that. We also have the velocity, of course, which oh, thanks, Kiel. Thank you. Yeah, so this is supposed to be the dampening, which I think I made a thing. I did, didn't I? Oh. Call this VDamp. Okay. Yeah, maybe I should put this inside of thread data so that it's not, there's no lookup like this. Like this has to kill cache, no? Right? Maybe. Maybe not. Yeah, I'm gonna totally clean this up now. Get rid of all this. This was some attempts that I had to spread the influence around the first one. Also, we could totally just like put this inside of one loop. These don't have to be separate loops. There's no... First of all, this isn't really a loop. This is literally just, this should be equivalent. It's just like the SRC into SRC. That should be equivalent. Oh, we're defining it twice. Let's just add an S, I guess. You know what's actually cursed? I think I have two DDXs. Do I? No, I don't apparently. Okay, every variable is every namespace for the variables are taken, so we're just gonna pretend like that isn't happening. This should be equivalent. I do feel like we're getting a lot of stuff though. And it's cool, it's just like, I don't know if it's correct. I don't think it's correct, actually. Oh, that's sick. That's sick. I don't think it's correct, though. I don't know why it would be different. Like, what? Is it this? Yeah, I have changed the camera angle, just because of the way the setup is. Since I got this new desk. I just want to make sure that these are the same every time. That it has to be. Yeah. Okay, so they're guaranteed the same. It has to be the same. It has to be the same. I wonder if it's just because of this new stuff that I did. Yeah, I bet it is. It's probably the stuff that I did with the border. Yeah. Haha, that's cool. How was your birthday party, sir? What kind of things did I do? I didn't really do anything. I just kind of spent it, you know, my dad made some burgers for me. That's pretty much just how I spend my birthdays. How do I practice concepts like recursion, stacks, queues? Well, for recursion, I mean, I guess my chess engine is had a lot of recursion in it. I I'm not really sure about stacks and queues. Like, what would that entail? Like threading? Threading is pretty difficult, yeah. But I mean, if you want to, like, you know, figure out how to do, like, you know, in terms of like queues, in terms of like, you know, threading jobs and stuff like that, there's like a bunch of different projects you could do for sure. Like in this project, I've learned a lot about threading for sure. Just because of how it needs to work with very little resources. I'd also recommend, if you want to get good at programming, don't use a good computer. You know? Like, use a very limited CPU. If you want to do like low level stuff. Yeah, it's the border 100%. I think it's kind of sick though. Alright, let's get rid of it. Goodbye. That feels emotional. You know how many, like, you know, hours of my life I spent working on that loop? Letting go of that is a lot. That's a lot. Okay, so let's start organizing this now that we've kind of cleaned up the function. What will be the output? What thing am I making? I was drawn to Lenia because I thought that it looked cool, right? I thought, man, that looks so organic and sick. And so, you know, when I brought it to 3D space, I was expecting it to look organic and sick, and it did, right? But then, you know, the further I got into like implementing flow Lenia and stuff, I found this other sort of math that I could do with it, right? That hadn't been done in 2D, because in 2D it looks boring. Why are the comments of mine getting deleted? I'm not sure. I'm getting most of them, or at least I'm reading them. I'm sorry if that's happening. I always forget to put it on. I always forget to put it on live chat. I have it on top. But yeah. So basically, I'm making my own take on Lenia now, basically in 3D, right? So it's like kind of my own take on it. So that's what I'm making. But I just kind of wanted to make something that looks cool, and I think it looks fucking cool. So you can just kind of press the random button and then like play around with it. I think it's sick. I'm not sure how much of this stuff is actually in use. We have to read through the code. I don't think that render lock is being used as a thing. So this is all the thread stuff. This stuff is kind of insane. As you can see, I have to have a lot of different incrementing numbers that tell us if we've done something already, you know? Well, you don't know, but you know. This halted boolean, I'm not really sure if this is going to stay a thing, but it was an old thing that's used for rendering. This edge array is very important actually, so that's still a thing. Yeah, I was wondering if I should like not, oh actually this isn't a thing anymore. This isn't a thing anymore, because now it's a much more, you know, cache friendly layout. Where is this? This can get rid of this, I'm pretty sure. Yeah, this is super old. Where's this? This is there. Where's the actual edge? Oh, is it on thread data? Is that what it is? T edges, yeah. T edges at array.edges, yeah. So we can get rid of that now. Don't know if VIDX is working, is a thing anymore. I don't think it should be. Because we use God, this is so complicated, this code. Yeah, OIDX equals VIDX core buff. Yeah, so let's get rid of this. Yeah, I am just trying to clean up the code base because I know it's like an absolute mess right now. I'm just gonna have hyperparams up here. Neighborhood is randomly generated by random, but it's technically a hyperparam. Yeah, let's take the whole thing. Yeah, the running doesn't have to be, but it's. These width and height don't actually do anything during runtime, right? But don't know what DT is used for. AI seriously stir outstanding from prompt to generative AI. I'm not sure what you mean. It is outstanding, the AI stuff. I think the technology is crazy. But do I think like it's being used well? Not really. Not really. This VI offset. Why the same comment getting deleted? I'm not deleting anything. And I don't think anything you're saying is getting deleted. I'm responding to it. Okay. So everything is kind of in order now. Like this is kind of like draw buffer rendering stuff. This is like the thread stuff. This can go up there. I gave the AI your video link. It helped you explain and summarize, even summarize the lines of code via my speech transcript. Interesting. You know, I'm free to answer any questions that you have. You know, if you have any. This pause array doesn't matter anymore. What that pause array is used for, by the way, inside of their implementation of like old flow linear is this. Literally, it just stores the position plus 0.5 for each of this. I'm trying to think like if that's even worth it to implement again. It would save a lot of this and that and blah blah blah, but wouldn't we still need maybe we wouldn't. Yeah, it might make us faster. Oh, but we still need this. We still need this down here. Do free code camp videos? Yeah, I don't know if I'm good enough to do that, to be honest. Maybe one day if I have the, you know, the confidence to do it, but yeah, so if we get rid of this for now, like technically it would be faster to use the pause array for this stuff. Yeah. Actually, so let's refactor this then. Instead of having a pause array struct, we should just have them as 3 different arrays and not have them as a struct. Like, it's a really stupid idea. So let's just get rid of that idea completely. You're lying. I know that this is a thing. I know that this is a thing, and it's inside of this file, and I'm going to find it, and I'm going to find you, and I'm going to be mad at you. Yes, it exists. Oh, it has an underscore. My bad. Where did I learn all this? From my IRL classes. No. I learned this from doing it. From just like doing projects. I had one coding class in high school, but this isn't in this file, by the way. I'm just scrolling the file for no reason. It's inside of here, over here. There we go. I just code a lot. That's all, you know. Just imagine like if you just coded every day, like for a very long time, and did it all of the day, you know? Like I don't really, you know, I don't do many things like, you know, not coding, you know? So, does that... Did I explore the other domains of computer science? I mean, I just kind of do projects, you know, of things that I find like interesting. So I've naturally like gone into like other, you know, things. depending on the project. So yeah, as far as like web development or anything like that doesn't really interest me now. So what this allows us to do is iterate it a different way instead of going like this. More cache friendly way, which would be like this. However, now we can't have an oscillator, but we'll have that in a separate loop at the bottom. But for now, what we'll do is int src section, and we'll just do this. But, you know, this will be grid size, right? So we'll do it the other way. What this is doing is it's just splitting up our thread sections, so that we're not doing the same stuff and we're not, you know, touching the same memory. So now 20s/30s of roll are available. Yeah, it's crazy. Okay, so there's that, and now we don't have to calculate src, we just have src now, and we get int x, we derive it from the pos array. And there we go. And now that x, y, and z have the 0.5 baked into it, so that we don't have to add ever again. So we can just get rid of the addition. But yeah, we do lose some flexibility with the things that we can do here, but hopefully it's fine. The mx, oh yeah, so that still does matter. Oh, actually, yeah, we can actually just do pos array midx. I don't know if the lookup is worth it, but let's just do it because why not? Do web dev, it's really interesting. And the database gives the requested things. Yeah, I'm sure it's interesting. I just want to make sure here that this is an integer. I think mx. I think I'm supposed to be using fdx here. Why am I using mx? Oh. Okay, so hold on. I'm doing this kind of wrong. I'm flooring it, but it's already an integer. What I want is I want a floating point version of this, basically, for the correct thing. And this is going to be this, but I need to fmod it. Like that. Yeah, because it needs to be in bounds, and it needs to be It also needs to be absolute value. I'm wondering if I take that before or after. Stack Overflow selling users data to OpenAI. Users now suffering. Stack Overflow is ended? Really? I'm not, you know, I don't really, none of that really concerns me, to be honest. But that's funny. Maybe you wanna maybe you want to do it afterwards. I don't really know how negative modding really works in this scenario, so I'm just gonna do it afterwards. And then this can become MX here. Do not forget to turn this to Y and Z. Do not forget that. Do not forget that. Do not forget that. And now all I have to do is, I'm just gonna straight up cast it to int. Yeah. 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 Okay. So now we'll use this down here to actually calculate the velocity shit. Okay. Okay, so it's mad at me. Okay, that makes sense. Okay. Ah. Okay, I feel like we fucked something up because that's not supposed to happen like that. Or maybe it's fine. Maybe it was just how we had it was bugged. Oh, that's interesting. Oh, I think it's because we got rid of the oscillator, probably. But it's interesting that it's all going in the same direction. That's probably a big problem. Yeah, it's all going in the same direction. Which means that we biased it somehow to positive because it's going into... See how it's going positive, positive, positive? It's positive Y, positive Z, positive X. Control U. Yeah. Yeah, I can see how all the growth is going in the same direction. Okay. It's three-dimensional DX9. That's what it means. It should technically be the same if we just do this, right? See if it's still biased. Yeah, it is. See how it's all going into that corner? Yeah, the biasing towards positive, yeah, it's all going that way. The biasing towards positive is something that I've been fighting for multiple days now. It is not easy. Let's try running back certain parts of it before we freak out. Okay, this one doesn't seem biased. Oh, that one definitely is going in the same direction, yeah. Yeah. I wonder, sir, how they don't get banned. You know, there's like laws for different countries like that, you know? Isn't this supposed to be MIDX? Or not? Or am I... No, it is supposed to be SRC. I think it's the pause array itself. Like if we go back to doing this, I'm like 99% sure that that's going to let's just call this like LX equals X plus 0.5F, just like do this. And then replace everything with that, just to... Oh. Why haven't I uploaded all of my projects? Because I just don't think all of them are worth really seeing. I kind of like am Kid, wait. I'm very I think quality is important, so it's not that I'm critical, I'm trying to not say critical. It's that I just like I care about the quality of the things that I make public, you know? So it's all flowing in this direction, in the same direction, yeah. So this is still biased. Yeah, I might just run it back, I guess. I don't really know. I mean, then again, this was a part of it, but this actually should make it more biased, technically. Technically, this should make it more biased. Okay, I'm surprising. Yeah, there we go. What do I think is missing in modern day dev that you people used to do back then? Uh, I think. Honestly, I think that the same problem is in development is the same thing in just society in general, right? Is that products are not made for people that don't have money. Like, like products are made for the people who can't afford them. There is nobody making computer systems. There's nobody making programs that normal people should be able to afford, right? It's the same problem with literally anything. Like, let's take fucking, I don't know, hair products, makeup products, L'Oreal, fucking whatever. It's all, like, nobody cares about, one, making things affordable, or two, making them for people who, can't afford them, or so there's a certain level of greediness that is just present in everything nowadays. um it's yeah, I mean, but it's the same problem with anything. It's not just programming. Free software does exist, yeah, but I mean, it, like, that, like, it's not, I don't know. I don't really think, like, first of all, free software just isn't up to the same standard of quality. Not to knock any, free software, people. I love free software, right? But I think that there should be, things should be affordable, and not only be affordable, but made for people who can't afford them. We have to stop acting like it's normal to spend fucking $600 on a GPU. That's not fucking normal. You know what I mean? That should not be the expectation. That should not be, like, the gatekeeping into, like, into culture. Like, we should stop making, like, cultural media that you have to pay $600 to consume. Like, it's fucking, it's classist, it's bullshit, it's awful. It's like that with everything nowadays. It's the reason why movie theaters have died, because now you're expected to pay for all of these subscriptions a month so that you can watch them at home on your big TV, even though most people can't afford to do any of that shit. You know, um, yeah, it's just awful. Like, it's like that with everything, like, literally everything. Like, getting a car, for example, you go to get a car, right, from a dealership, except it's been refurbished and, like, guaranteed that there's just shit wrong with that car, that you're gonna have to take it back to the dealership for them to work on it. They have the code readers that tell you what's wrong with the car, so that you have to bring it back to the dealership so that they can fix it up, right? You can't, you have to purchase the equipment to read the code yourself, right? And so it's literally rigged from the start, right? It's rigged from the start. Like so many fucking things, right, are just rigged from the start. It's rigged for you to, everything is rigged to break so that you have to replace it, and so I don't know. It's just the whole like modern tech everything is just shit. Just to be honestly, fortunately, nobody can work for free. Businesses have to pay their bills, but business owners are greedy. Yeah, I mean, people have to get paid. Yeah, I completely understand that. But do you know how much people get paid? People do not get paid. Like, people do not get paid. That's the exact argument I'm trying to make here. Like, nobody can work for free. Yeah, I know that, but the fucking heads of the company should not be making half of, the entire, the gross earnings of the company. Do you get what I mean? Like, if nobody can work for free, then why are the fucking people that wear the pinstripe t-shirts making $15 an hour when they sell more than $500-600 worth of product in an hour? How does that make any fucking sense? You know what I mean? Like, nobody can work for free. Yeah, but they already work for so little, and nothing is affordable. Like, it's just everybody is taking advantage of and thinks like that's normal. It's not normal. That is not normal. It is absolutely not normal. But you know me, I love to get on my soapbox about it, but yeah, it's like it should not be like normal to like, Yeah, I don't think this is going in the same direction. EV's cars are sustainable. Yeah, I mean, cars will never be good for the environment. I don't understand why we try. Like, we should just make, like, in America specifically, we're so greedy that we don't make cities even have transportation. Like, you literally have to have a car to live if you don't live in a major city in America, because there are no fucking buses. Like, maybe you don't like know that if you don't live in America, but there's literally no transportation anywhere. I know so many people that can't afford a car, and so they have to like bike, right? Like, that's a real situation for people in America. So it's like, I don't know. That's truly awful. Yeah, that's just whatever. Like, I would be fine with things like costing more and more money every year if people were making more money, but it's just not, Every job I've ever worked, right? I sold so much product, right? And I was paid like one like tiny like 0.1% of what I sold, right? Like every job I've ever had, right? And so I feel like that's just the experience for most people. I think most people just like don't pay attention to it, or like don't care, or they just like think that that's like the way things are. But that should not be normal. That should not fucking be normal. People should work and get paid for their work, the value of their work. You know what I mean? It should not like be that you work for like in such a big margin. I would understand if like you get paid for like 5 to 10% of what you sell, but it should not be like that gross. It should not be. Yeah, so I don't know what the hell I did that this is so bad. Where is this shit? Yeah, sorry, that shit kind of gets me in a bad mood because I have a really hard stance on it because I've worked some, a lot of really bad jobs in my life, I feel like most of the people that like say stuff like, oh, it's not that bad or whatever, may have gotten lucky, or they, for whatever reason, just like, I have not been that lucky, right? But yeah, trust me, it is pretty fucking bad for like the majority of people. It's really bad. It's really, really bad, it's just that you don't like see them or think of them because they're like the people who are bagging your shit at Target or whatever, but it's really bad. It's really bad. Okay, so the pause array seems fine. Actually, maybe not. It'd be nice if I had like a proper control group to be testing this with, but yeah, it doesn't seem to be doing it. Yeah. Maybe it's slightly biased, but it's always moving away from us. That moved towards us. Yeah, it's fine. Also, was this supposed to be, this is MX, so this is supposed to be MIDX. Oh wait, yeah, it is. Yeah. It is. I also like, I don't think like it's like a thing where it's like if you look at like history, right, like people who have power always take advantage of people who don't have power, so it's like I don't really think it's like it's anything that like can be solved. It's just kind of like something like endemic to like human nature, so it's not like I don't really like care about it that much. That's the same reason why I don't want to be rich and I don't want to be powerful. Like, I don't want to be rich. I don't want to work for a big company. I never want to, because I will become an asshole. It's just the way things are. Once you're rich, you're an asshole. Like, it's just the way things go, Yeah, so apparently I want to implement this again and it not go to shit. I don't know. I'm not even rich yet. I don't know. Yeah, I mean, You don't have to be rich to be an asshole. That's for sure. That is absolutely for sure. Hey, Isabel. This is... Yeah, I don't know, like, why this biases it in a certain direction, but I'm just gonna write the code that I just wrote again. Yeah, so this is... We just have it inline now, but it should be the exact same thing. Maybe it was because I put SRC on here. Okay, I think that that's correct. Oh my god. Was... Okay. So far, not so bad. Okay. Okay, I don't think it's biased. I think we would see more movement to the top left. Top right, I mean. Yeah, I don't think it is. Okay, well, that's good. Yeah, I think I probably just, like, wrote something incorrectly and didn't see it, so... what else was I going to do here? I kind of forgot what I wrote, but... Oh, yeah, that's what I was doing. Oh my god. Yeah, so that's probably what it was this stuff that I did that probably biased it. Yeah, that's not good. It was this fmod that I did here that probably did it, but like, I don't know how to do this without this. Like, how is this any different from this? Like, it should be the same thing, unless I need to do this to periodically wrap it. Probably. This is probably what I'm supposed to do. Okay. Okay, let's see if this works first before we do anything else. If this if MX works like this. But I need a floating point version of this to do the stuff correctly. To do the stuff correctly, you know. It's complicated. To do the distribution of the velocity correctly. Okay, I think it's fine. The weird, like, you know, strips across is pretty interesting. I don't know why that's happening. It may be happening because of the border. We have, like, a weird border setting right now. Okay, this looks fine. Okay, so yeah, we just had to add this to periodically wrap instead of the regular wrapping. So okay, now for the real thing, which is this. This is gonna be the real test, I guess. Okay, I think that we got it this time. Oh no. Ah, shit. Yeah, it's doing it again. God damn it. I think it is, yeah. Yeah, it's going in the same direction. Oh, dude, really? 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 I wonder if I did the ordering on this wrong. I just, like, I looked up the table and I just did the ordering the same. But man, that's a bummer. That is a real bummer. Because this was essentially 0 before, because this was already the same as the floored version. Because this was already an integer. This is an integer. So we were doing it just as a single, you know? So yeah. Yo, what's up, Oops? Nice to see ya. Let me try the periodic wrapping. It probably won't do anything, right? But we can cope and attempt here. So basically what this is doing is it's just getting us 2 different cells, right? But we still need this minus this to give us the weight, right? But yeah. It is a bummer. If that fixes it, I'll be so happy. I'm not seeing it. Ah, no, there it is. Yeah. Yeah. Got it. SAT triangle after I implemented it. Isn't used that much in 3D, yeah. Yeah. Yeah, you should ask Arya. Arya knows about GJK. Yeah, it's biased. Fuck. Oh shit. Okay. Let's just make sure that this matches up completely before we crash out. I may crash out. Okay, we can crash out. God fucking damn it. Okay, let's see if there's a typo here before we crash out. Okay, there's no typo. God, that sucks, man. That sucks so bad. Yeah. Yeah, it's... So the problem with the math that I'm doing now is that basically if just the tiniest thing is biased positive, right? It just everything will flow in the positive direction. So it's very... Is Command D? What is... Command D? I don't think they got that on Windows XP, bro. thinking I could still make something usable. Volume entity. Make a voxel grid and use SAT. Interesting. Yeah, you probably can. That's kind of what I had, pretty much. Yeah, I literally just had a voxel grid, full of triangles, basically. So that's like literally exactly what I had. Basically every voxel just had, you know, a bunch of things in it. You have to select a word first. I don't think they got that, bro. I don't think they got that. Yeah, I don't even know what to do in this case. Like, what am I supposed to do? Does CalcPause, CalcPause does not wrap it. Oh, but CalcPause, but it doesn't need to wrap it because we already are wrapping it here, right? Yeah, that works fine, I think. Yeah, that works fine. Let's think about how we're iterating though. Because we may be like biasing things positive just by accident, I guess. Maybe we don't use FabZF and then we... should probably implement static objects on top of that. Manually assign entities to a voxel grid. Yeah. Yeah, vertex lighting is really awesome, yeah. For sure. You should definitely do that. I think it's just like a really it's a really like elegant solution always to use like a voxel grid, even though I think like most, you know, big engines don't, I guess. I mean, maybe they do, but for me, it just kind of like made sense when I did it. But I did like think like later down the line, like, oh my gosh, like what if it's like, you know, inefficient or whatever. Like when it came to like actually doing like collisions and ray versus triangle stuff and all that, like it became like a little bit inefficient, you know? So I suppose if you have like a lot of that stuff happening, it's not like super efficient. But yeah. Yeah, maybe let's not add grid width here. Maybe let's not add grid width here, because there's a possibility that that's negative. Yeah, there's a possibility that that's negative, and then that's throwing things off, I guess. Like, I guess. It's still happening. Yeah. I know about latex. Yeah, like they put in gloves. Plan to do a BVH. Yeah. Do like an octree or spatial hash. Yeah. Yeah, BVH is pretty good, yeah. I did implement like a BVH near the end, but yeah. I never did like a spatial hash for anything. You know. Yeah. Yeah, that's probably a really good idea. It's kind of hard to know. I guess what I want to do is I want to the tricky thing is that if we're biased positive, it might just be this. Like, here's what we can do, right? Is we can just, like, actually, I'm just going to sum it up, and then we'll just actually see if the sum is positive or not for the velocity, because it's possible that we're just biased positive in our velocity, and we have to just subtract the mean to normalize it properly. Only do that for the root node. The only node that constantly gets recomputed is the scene node. Yeah, that makes sense. Well, that's good. You got it kind of figured out, huh? I hope that your computer isn't broken. I hope that you know, whatever happened was good. Ended up good. I know you said that you had some problems. I'm just literally going to do this. Oh my gosh. I didn't really expect this to happen. Let's just print, well, we can't just print f like that. So we're just going to try and get the sum down. Okay, so let's just do this. Output debug string A. There we go, and we will check that out. Which is a BVH full of points. You had a ghost compiler keeping your bad include alive. Oh, wow. That sucks. Yeah, that must have been hard to figure out, huh? I would have assumed that something was messed up with my libraries totally. Yeah, so it's kind of all over the place. I guess what we can do, I guess, is actually just iterate it once, accumulate the velocity, and then normalize it, and then do this. And then we can just absolutely make sure that this is correct, I guess. The weird thing is that we have to only do our section for the velocity, but it shouldn't matter. Shouldn't matter. So let's just do this. That's kind of sucky that we have to do this, but we have to center it, I think. Yeah, we just literally go through it again. Yeah, so we have int len equals the end minus the section, and then that's what we are going to divide by. Seemed like first it had something gone deeply wrong. Yeah. Yeah, I would have probably assumed the same. That does sound like pretty bad, yeah. Yeah. I've had some stuff happen like that with like libraries before where it's just like it just breaks. And that's really scary, yeah. And so now we just have to subtract everything by the okay, so now everything is centered around 0 with our velocity. So now if we still are going into the positive, C, undeclared identifier. Oh, right, we have to iterate the channels as well. Just do it here. It did it all on its own. Yeah, the Visual Studio is very interesting. I could definitely see them doing that. It being responsible for that. I could definitely see that. Okay, so now we're centering everything around 0, and it still is happening. We can try and prove that it's centered now, but yeah, I'm pretty sure that it. Alright, peace out, Shari. Have a nice night. Okay, so I just want to prove that this sum is going to be around 0. Oh shit. Wait, hold on a second. Hold on a second. What? Oh. I did this wrong. This has to be times channels. Yeah. Yeah, I didn't know about Writer until you mentioned it. It does seem pretty neat. I did not know that it existed. Yeah, it's still biased. Yeah, I think so. Yeah, it's all going to the top right. Yeah, it seems pretty interesting. Yeah, I mean, so my experience with like IntelliJ was like when it was, I think like it was only a Java thing. At least from what I remember of it. Like back in the day. I didn't think that they had anything else. but maybe I'm remembering it wrong, but yeah. Maybe if I try doing it like this, it's fine. Like Visual Studio works across all platforms. Yeah, that's what I hear about it. Yeah, when I did Java, I did it on, you know, NetBeans sort of thing, and Eclipse. But I remember that they had the idea or whatever. It always looked enticing, but it was always expensive or whatever, so I never paid for it. You know. Yeah, it's whenever this is not just a flat amount, it biases it. What? Is that the wind? It was like the scariest thing in my entire life. Oh my god. It sounded like somebody was pounding on the door, but it was actually just the wind. It's like, what? Yeah, the wind is going crazy right now. C# works across all platforms? Yeah, I thought that it was like a Windows thing. But maybe it does compile across all platforms. How do I even test if this is like maybe it just inherently just flows positive. I don't know. I don't even think it's because of my coordinates at this point. I think it's just genuinely the free tier wants you to not close source your project and sell it unless you pay for a paid tier. Really? Is that what it is? I never really considered it. Also, you know what I should be doing is like I should be testing the other border. That's what I should be doing. I don't know why I'm just not using the border to test. Yeah, I don't know how they enforce that either. If it was the border that was the problem the whole time, I'm gonna be kind of annoyed, but at least I figured out what it was. Okay, I'm trying to find a good example here of something that is movement. Okay, it seems like it was the border, actually. If it's fully compiled and shipped, I doubt that they can do anything. Apparently they have an AI scan. Interesting. Yeah. Their IDEs always look neat, and like people were recommending me to do C-Line too. So I think that it's probably like good products. I do kind of like the like, I don't know, the whole like free software sort of thing, but there's just no like Nobody in the free software world is making like an IDE. I don't know. So PyCharm and IDEA have always been free. Really, IDEA? I thought that when, I don't know, when I looked at it, at least it was paid. I remember there was like a free version, but I mean maybe that was just when I, you know, looked at it. But then again, that was like, you know, 8 years ago or whatever now. So okay. Oh yeah, so this, we can't do this anymore unless we subtract from here. Which kind of like defeats the whole purpose of this, just like casting it to an int, but whatever. I want to test out the oscillator just to make sure that this works. It feels so sucky that I was stuck on this for like 20 minutes, but it turned out to just be, you know, something completely unrelated. So I prefer IDEA over Eclipse. Yeah, I mean, Eclipse always sucked. Like, I'm not gonna like defend Eclipse. Like, man, Eclipse always sucked. Like, it just was bad. PyCharm is the best Python IDE. Yeah, I think I used PyCharm when I was doing some Python scripts, but I've never like done a lot of Python, but yeah. Yeah, I think, yeah, so this is fixed. I do like NetBeans, though. I don't know if that's just the nostalgia talking, but I think NetBeans was what I always wanted an IDE to be. It's just, like, very simple and nice to look at. Eclipse was ugly. That's my problem, to be honest, with Eclipse, is that it was very ugly. Eclipse is like the ugliest IDE ever made, for sure. 2 hours of Python experience, all you don't like it. Yeah, it's like Java, but like, you know, it's like Java, but even worse. I mean JavaScript. What am I saying? Java. I don't know what's wrong with me. Yeah, it is cluttered. There's just so many buttons in Eclipse. I don't know. Yeah, NetBeans was what I learned on in school. I've only used Python's built-in IDE. I didn't know that they had that, to be honest. I had no clue that they had that. Alright, so that's that. I don't know what's the... I wasn't really paying attention to the performance of this, but apparently it's fine. I didn't see how much... I don't even know if we need to do any of this shit anymore, to be honest. We should actually check that out. I don't think that we need to do any of the velocity centering that I was fucking doing, to be honest, if it's wrapping modulus around the thing. Yeah, I don't think it's flowing in a certain direction, so I think that it's fine. Yeah. VS Code, the blue one. Yeah. I don't mind VS Code. I think that VS Code is probably good for like, like small projects. It's just you cannot use it for a big project. It just does not scale well. I think Python is great for like if you're like a mathematician or like a scientist or something, then like Python is like probably the perfect language. You know? Like I want to show you some good Python code. Where is this? Yeah, so the flow linear stuff that I've been working on, right? So I want to show you their code here for doing it, right? Like, so this is why Python is such an incredible language, right? And why I don't like it, because I have to read the mathematician code, right? I have to read this shit and then turn it into C. And I often misread it because it's, the syntax is fucking stupid. But this is why it's such an amazing language, right? Because you can use something like JAX like this. And this is like, by the way, this is like 400 lines of code for me in C. And here it's like 10, right? Let me walk through. I can't read chat right now. Let me walk through and, talk about what this does, right? So this just, this is a single variable that it makes. This adds an entire array. This creates an entire array by the way, this is 4D array. This is a 4D array that it makes in one line of code. And then it calls this function, right? It makes another array in one line of code, another array. And then it goes through, and then here it is making another array by subtracting just every element in the array, and then here it's doing like a ton of math just in line for the entirety of this array, right? And that's just how it works. So that's why I think Python is an awesome language if you want to do like actual like math, So after a while I moved to C#. I was like, why didn't I do this sooner? Yeah, C++. I mean, just like C and C++ are just always going to be the, I don't want to sound like a jerk, but it's just the best language. Like, it just is, right? There's not like really a lot of like argument that could be made, in terms of like, it's just kind of the best language. But yeah. Yeah. Yeah, exactly. Like Python has NumPy and JAX, which are like libraries where I've had to implement the array rolling, all of the convolution stuff by hand in C. That is done for you in so many easily accessed libraries in Python. It's incredibly, it's impossible for you to get the same thing in C or C++. You have things like the GNU Scientific Library, right? You have things like FFTW, right, which is great, but you don't have things like NumPy and JAX. You don't. So that's, the reason you use Python, right? C#. Yeah. I'm right there with you. I don't really see the point of there being really other languages, to be honest, but there are, right? I kind of just wish that there was NumPy in C. Apparently, like, you can call it from C or something like that, but yeah. I don't even use this lookup table. I can just get rid of it. Okay, so we implemented that stuff. I was supposed to this is still slow, but it's fine for now. I was supposed to move some of these parameters into the UI, so that's what I'm gonna do next. Yeah, I don't think I would really use another language now, unless it was something that like for example, like if I wanted to make like a website, you know, like I've got an idea for like this cool website I want to make, to be honest. There's like I want to make like a color theory website where you can like pick out palettes, right? And like do some interesting things with like randomizing and like, you know, picking out, you know, palettes based on certain themes or whatever. People have done this before, but like the biggest ones are all like subscription based, which is like such a bullshit, dude. Like it should be free. It's a color palette website. So I wanted to make something like that, but it's like I really only know C at this point. It's not like I can easily just be like, okay, time to, you know, do JavaScript. I would literally like have to sit down and you know, realize like how to do that. I attempt to move into Rust. Rust is cool. I don't know. It's like I think what Rust is trying to do is pretty cool. It's like it's different than C, right? It isn't just trying to be C or C++. But it's not fun to write. So, you know, if I was starting a company, I would make it in Rust. Because it's just better to scale clean, good code with Rust. But it's not fun, like, to write. You know? It's just not. It's very unfun to write. Okay, so where am I gonna put these goddamn buttons? So first of all, I don't have channels buttons, which is probably like a mistake. I should like plan out what I'm doing. So let's take a look at the list. So we have GTA 5. We have STA. And these are the temporal averaging parameters. And then we have the V beta and the V damp. And these are the globals. These are the globals, right? And we also want to make borders switching. So let's put all of that shit at the top. Okay, so yeah, so let's make a button that switches the border type and switches between the three things in the enum. Now, is that going to be a pain in the ass? Yes. I don't really know how I'm going to do that. I'm just going to make an array with this in it. So that's what I'm going to do. Yeah, the compiler does scream at you a lot, and I don't know, maybe I'm just different from most people. I just don't like getting screamed at. That's just me personally, right? Like, we may have some people here that are like, you know, I love getting screamed at. But me personally, give me mystical errors. Yeah, the thing is about that is a good point though. Like, I got like really good errors from my compiler in Rust. Like, yeah, it yells at you all the time, but it tells you what's wrong. It really is good. I think it's actually, in that way, it's good for a beginner because it tells you what's wrong. like if you're a beginner getting into your first languages, C++ or C, you know, you're kind of shit out of luck, you know, if the compiler, you know, gets mad at you and a simple Google search doesn't tell you what's wrong. So in that way, I think Rust is actually, you know, good, but I don't like hate Rust at all, right? But I do despise people. Like I was talking to somebody like a few weeks ago, right? And they said something like there's no reason to use C in the modern age. And I was just like, you know, like I was just bewildered, right? And so I said to him like, you know, no, he said to me this. He said there are hot take. He pinged me in Discord. He said hot take. There is no good C programmers. The language isn't expressive enough, and I like almost lost it. I was like, I mean, like seriously, that was like, that was crazy to me, and I was just like, yeah, I've got nothing against like Rust or any other language. Like all the new ones, they're cool, man. And he was just like, yeah, it's not about Rust. It's just, you know, there's no point in programming C anymore. And I was just like, I was like, you know, the Linux kernel. I was just like bewildered. You know, I sent him some like really good C code, and he was like, I don't think you're getting my point. And I was like, dude, like dude, like what? Like I was losing my mind, and it's just like I don't want to be like, you know, a boomer here or whatever, but dude, the Zoomers that like love like the new Zig and Odin and the this and the that is like, they're just like really, dude, like it's just ridiculous. It's super obnoxious, dude. Like, whatever, man. Whatever. Yeah. Anyway, like I don't get offended by like it's obviously like that they're just like, you know, young people, right? But it's just like that's like genuinely like the type of shit that I see on like Reddit and on like Twitter and shit is just like, I don't know. It's like people treat programming languages nowadays like NFTs or some shit, like, you know, like some hot topic, like, oh, you're gonna make the new language, you made the new Zig, you made the new, like, dude, like, can we just like, what's wrong with C? Like, genuinely, what's wrong with it? Tell me. Always goes on about Rust. Yeah, I mean it's not just young people, but also like Rust is different. Rust is fine. It has nothing to do with Rust. I think like most of the things that I get annoyed with are like the other new languages, you know? C is the default language. Yeah. Yeah. Rust will kill C, yet it's, yeah, C and C++ will never be dead. They will never die. And there's, you know, plenty of good reason for that. Why is RI this high? That's horrifying. What did I do? Wait, what? Should I be concerned about that actually? I was kind of talking and not like thinking about what I was doing. That's an incredible, that's an incredible amount of time. Zig and Odin are just C reskins. Yeah, you should tell that to like all the kids who are shitting on C all the time. Okay, so yeah, I messed something up real bad somewhere here, in terms of performance. Is it actually just the just the oscillator that I have hooked up? It might actually just be that. Oh no, it isn't. Why? What did I do? 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 Oh, is it actually just Uh, just this. That's the problem. Just the fmodf sort of thing going on here. You hate to see it. You genuinely hate to see it. You really hate to see it. Where am I using it? I'm not using it anywhere. You're lying to me. Oh, I'm using it right there. Oh my god, dude. I'm so annoyed that this is going to be annoying. Oh, yeah, it is. Oh my god. Fmodf, man. That's so cursed, man. Oh, shit. That's so bad. The amount of times Langs have come by with all fancy... Yeah. Yeah, I mean, they just die off, yeah. I mean, like, I'm not gonna, like... I don't be mean to people, right, who like these things, right? But they are mean to me. You know? So... I think it's genuinely, like... I think it's actually just, like, it's personality thing, right? It's like, I feel like it was this thing when I was like a teenager, right? Where it's like, I wanted to be, you know, accepted by like people, you know? I did it like with friend groups in high school. I did it with like friend groups online, right? Where at like the start of the friend group, right? I would like when I was, you know, getting into it, I would like, you know, try to be like them and stuff like that. I think like it's the same thing. Like it's just a bunch of like people that want to be like other people and they don't really, I don't know, see the forest for the trees or whatever. I think a lot of things are like that, to be honest. Yeah, there really is no need for the fmodf, technically. When we can technically just... Okay, so there's a very convoluted way we could go about doing this. I'm about to write some cursed fucking code. I hope you're fine with it, but it's about to be really nasty. Okay, so here's what we're gonna do. We're just gonna use the integer version, right? And then... Okay, hold on, lock in. Okay, so we need to get this casted to an int first. Yeah, we need to cast this to an int. And then we'll take the floating point end of it and then just put it onto the other part. Like, legit. Okay. We're gonna call it LMX. It's this. Okay, so we're gonna get the version that's casted to an int. And then that's what we'll of course just use down there. But like making anything usable in assembly, it's really not that complicated, but yeah. It's not just the Rust kids. Yeah, that's probably something too. I mean, for me, I don't see it a lot because I like stay off of social media. Really, the only like internet outlet I have is, you know, my Discord and my YouTube channel. That's really like it. I don't have like Twitter or Reddit or anything. Literally, when I search something up, I Google something when I need help on something, and then I go to a Reddit link, I'm immediately reminded of why I don't have social media. You know? So tech YouTubers, yeah, yeah. Yeah. Tech YouTubers, man. I I enjoy them for what they are, but like I enjoy them as like entertainment, you know? Like I saw this like 10-minute clip of the primetime guy or whatever making a Commodore 64 program. And I thought, "Oh, yeah, that's neat or whatever." But um, you know, but that's really the extent of it. Okay, so wait, no. You need the not casted to int version of this. Yeah. You need the not casted to int version of this because this is this is what's going to be. Yeah. So okay. We just need to get the is flooring faster than casting to an int? Fuck if I know. It's fast. Yeah, it's also like literally assembly sometimes is just slower because C compiles sometimes to just faster assembly than you could write, right? Like that's kind of the consensus on it, you know? They're the kids who just got into Yeah, the thing is I was the same way when I was a teenager, you know? Like I had just gotten into like, you know, fucking talk, you know what I mean? Like I was that guy. I was so that guy. You know, so I don't even like you know, it's just young people, you know. But I was the same way with like my music taste and shit. When I was a teenager, for sure. At the end of the day, though, it was just like me being passionate about something, you know. But yeah. Anyway, so we need FMX. We need to get the. What is he programming right now? I'm trying to find a way to basically avoid the fmodf and instead just add the floating point part to the regular modulus. So we just go that. Is that legal for me to do? I don't know if it is. But or does it matter, like if you modulus, does it flip? Or does it not flip? Basically reverse engineering fmodf. But yeah, I think it's required because it slowed us down by about 4 times. So I think it's important. Probably. Okay, whatever. Yeah. I'm not like surprised though. Like when I was, I don't know. You get older and then like, you know, things stop mattering that much. Like, I have my, like, you know, my annoyances with the world and stuff, but the thing is, like, it isn't like I don't have anything where I'm like, man, this shit is so good and it's like better than everything else. I don't really have that anymore. You know what I mean? Like, there's just like bands that I think are cool, and there's like games that I think are cool, and there's like, you know, just movies that I think are sick, and I don't really care if they're better than anything else. I just think that they're cool, you know. What a partial game engine, Radiosity Light Mapper. That's crazy. That's fucking nuts. That's crazy. That's insane. Was that what you showed me with that video a long time ago? Was that engine? I didn't know that that was in assembly. That's crazy. 2019 Sonic Ether and John Lynn. Yeah. Yeah, that's awesome. You're very knowledgeable about stuff, so yeah, I'm not surprised that you're passionate about it, you know. So actually, so this was not it. So this is actually going to be F. Yeah. I don't know if I'm doing this correctly, but my idea is that we avoid the fmodf by finding the floating point portion of it and then just like adding it after we do the regular modulus. I have no clue if that's correct, but there's really no other thing that I can think of, so whatever. Also, we can avoid this florf completely and just use this because it's the same thing. That's something in WebGL. You have ASM clout? Yeah, I've got to get that ASM clout. Yeah, you are young. That's alright though. Like, I was definitely not, you know, in terms of like knowing what I was focusing on when I was that age. Like, God, no. I was not. Okay, so this just really pissed me off, actually. Oh, man. Oh, it's biased in a certain direction. Dude, like, what a fucking bummer, man. What a fucking bummer, dude. I just... Yeah. Dude, that's so stupid. Okay, so let's just, like, before I, like, lose my goddamn mind right now, let's just, like, literally breakpoint it and then, like, see what the values actually are, if I'm doing it correctly. Is it just 0.5 always? Like, what? Oh, is it because velocity hasn't picked up yet? So there's nothing here yet. Please go. Okay, it's debug mode, so it takes fucking forever. Okay. Okay, let's see what it gets to be now. It's still 0.5, just permanently. What, like this? We can't be serious. Okay, there we go. Yeah, I'm trying to get a good one so that I can actually see what's happening here. This is just permanently 0. Wait, hold on a second. Oh my god. See, this is why I should not, like, start yapping on stream, dude. This is why I should not start yapping on stream. Because I literally deleted the velocity. I literally deleted it. I was not thinking, and I literally just straight up deleted the code that does the velocity. I literally just, I deleted this code. I just deleted it. 2019 from VR, voxel tech. Yeah, that's awesome. I just kind of float from thing to thing, you know, but it's really cool that you're, you know, passionate about that. Okay, so let's see if now we're still biased, because it would be awesome if we weren't. Okay, but like, where's the actual error? Gotta get rid of these warnings, man. What? Oh. Oh, I'm in debug mode. Oh, man. Okay, are we biased? We are. We actually are. Okay. So that sucks. That does really suck. I doubt that we have symbols. Yeah, we don't have symbols. We have this. Yeah, so that tells us that we are getting actual floating point stuff now, but oh, actually, you know what? I think that this should be fabs, because yeah, I doubt that that's gonna fix the problem though. No symbols. Yeah. Yeah. 2019, most of these new pipelines were Frankenstein. Yeah, I like all the OpenGL stuff because it's well, I like all the older programming stuff. I don't know. I haven't really tried the newer programming stuff because I don't really have like a rig or whatever, but I don't know. From what I see about it, it's kind of like I don't know. I like more of like the kitschy kind of solo, you know, programmer sort of thing, you know. So I'm kind of attracted to that. I think that OpenGL is kind of all about that, you know. Yeah, it's so fucked up, man. It's so fucked up. Like, is this just going to work now if I do this and go back to this? Yeah. Shit. Yeah, exactly. Yeah, I feel the same way. I mean, that's why I'm kind of doing this here as well. I kind of like have to reinvent the wheel, like what I'm doing right now. I can't use fmodf because it makes us too slow because we are on this computer. You know, it's the same sort of thing. How does fmodf work? Yeah, it's not telling me. I just want to know like how the decimal wraps around. Okay, so if fmod is negative 5.1 and its modulus with 3, then it becomes negative 2.1. And if it's positive 5.1 modulus with negative 3, it's 2.1. Yeah, it looks like every example that they have, you can just keep the decimal part, but it's not working for me. Writing an OpenGL ray tracer. Yeah. Yeah, that is incredibly cool. I think all that's cool. I think compute shaders were always difficult for me. I mean, I did like a couple of them, but yeah, it was always kind of difficult for me to wrap my head around personally. So that stuff is really impressive to me. Yeah, I guess that we can see what the difference in the result is, so we can do like, we can just print them out, or just like step through them just to see what is the difference between these two different versions we have. It's the same thing. Wait, it's the same thing though. Wait, it's the exact same code. It's the exact same value. Like, maybe it's different cases. Because not just the aliasing, but doesn't line up with my G buffer. Interesting. Yeah, I wouldn't consider that mip maps would be useful in ray tracing, but I guess so. But I mean, I know nothing about ray tracing, so 24. Yeah, the denoiser stuff was pretty cool. I think that part of ray tracing seems like so interesting for me, just like the, you know, getting the fact that like the result of ray tracing is just like all these tiny dots and stuff. It's very, very cool. I mean, it's the exact same value. It's the exact same value. It's the exact same value. It's so strange because it's giving me the same result, but it's not the same result on the screen, which is pretty annoying. I should probably actually yeah, it's all going in that direction, I'm pretty sure. Yeah, the problem is if something is like slightly biased towards positive, everything starts flowing in that direction. Maybe it isn't right now. Oh, no, that definitely did. That definitely went that way. Prevent aliasing? Yeah. RT results into an RT buffer. Yeah, that stuff is crazy to me. I have no clue about any of that. That must be a lot of fun, though. I guess we could also see this side by side. Like, could see this side by side to literally just see literally two of them, because obviously this has to be different at some point, at some level here. You can only use the first 10 slots. I would love to continue here. Debug mode is so slow. It's so incredibly hard to... Okay, there we go. $19, 19.5, 19.5, 4.59, 4.59, 21, 21. I mean, I may literally like have to. Oh shit, there it is, 4.62, 4.62. What? Oh, it's because of the breakpoint thing. Oh, it must be in some weird edge cases because it's mainly lining up. It always lines up. Okay, let's just literally do the thing. I'm just being lazy. Oh shit. yeah, debug mode is, yeah. Bindless more modern structure. Have a shader ID texture on the G buffer. Global buffer like Doom to draw. Yeah, I saw the PowerPoint on how they did rendering in Doom. It was pretty incredible. Okay, so this is X is off here. So this is 2.5 and this is 2.51. So it's supposed to be 2.5, but we get 2.51. So this is 2.5, and this is 2.51. Well, I don't know why that is the case. I mean, I probably just like literally don't know how fmodf works, but yeah, apparently this isn't going to work. It works like for most of the time. Like actually like 99% of them it works. But for some edge case it doesn't seem to work, I guess. I want to see if we get another one. -30. Oh, wow. Wait, what? Oh, wait, what? Wait, hold on a second. That's a big difference. Wait. Uh, wait, what? Casting this from an integer? Made it go to 0. What the fuck? Wait, what? I guess that's not safe to do. Never do that. Never do that ever again. What? Wait, what? Wait, that makes no sense. That makes actually no sense. Okay, and now I'm not hitting the breakpoint. Okay, I hit the breakpoint. Okay, now... Wait, hold on a second. I think that... I think that this might be wrong, and then this is actually correct. I think that this is correct now. Yeah, I think that this is correct now. I'm gonna try this out. I think that that might be correct now. No, it's not correct. Placing simple TAA seems to improve it. Yeah. I have no clue. I didn't know anything about TAA before you mentioned it. I had no clue. It's very, very cool. Yeah, I think that this is actually correct and this was never correct. Or maybe that this was supposed to be plus grid width. I don't think that making it periodic matters. Well, shit, maybe I did need to center it. Probably not, though. It's giving you pretty good results. Yeah, it's really, really a neat idea. Yeah, it does seem really cool. Hey, what's up, Neural? It's going good. Prevents the first few indirect samples. Yeah. RV32I? I don't know what that is. Special ones have to reset when anything moves. Yeah, I'm not sure what's the difference between your spatial accumulator versus your temporal. Did test for each instructional pass. Congrats. Is that a processor? I probably have a bug here that I'm just blind to. Well, that's certainly, like, let's not cry over spilled milk here. Okay, we just have these, like, rounding precision issues, like, what is this, like, FMY? FDMY? Okay, yeah, I'm not sure why. I wonder if, I mean, adding this doesn't do anything. Adding 32 does nothing. Okay, now it's just gonna give me a bunch of BS though. Accumulators accumulate the last frame. Oh yeah. Burial ones just blend frame by frame and reset when something moves. I see. What are we dealing with right now? We're dealing with something really annoying. So basically, we are biased in a certain direction. I've been fighting this like for the past few days with the math that I've been doing. We're biased in a certain direction with the math, so that means that everything is flowing in to the top right. So you can barely see it, right? It's not like incredibly noticeable, but do you see how everything is moving to the top right? You see that? So basically it has to do with here. So when I just use fmodf properly, right, we don't have to deal with anything, right? I can just use fmodf and it works. The issue is that fmodf is incredibly expensive. Incredibly expensive. I need to have the velocity, the floating point part of the velocity, because that tells us how I'm going to, disperse it, right, once we go there. But yeah, so that's the issue, is that like we need a floating point number, can't use fmodf, and so now I'm trying to reverse engineer it basically. So when stuff is moving, if you don't reset the image, spherical one, it blends the new perspectives into old. Interesting. Oh, I see. Temporal ones can move the objects. Oh, I see. That's neat. That is neat. So one is just pretty much taking a snapshot, right? And then the temporal one, you're able to get vectors so that you can keep stuff in place, yeah. I see. That's interesting. That is really interesting. Yeah, so what I'm basically trying to do, Neural, is just like figure out a way to get them, get it working, I guess. Like I'm not even sure if this would work at this point. Like if we switch them, and test out if it works. Does it work? I wish that there was like an easier way for us to test it, but no, see, it doesn't even work anymore. The fmodf version wasn't even correct. Yeah, so it was never correct. So it is biased no matter what. No matter if we use that version or this version. So shit indeed. Spatial ones, you have the benefit of not firing arrays. because it won't work when nothing moves. Do I need to refire those arrays, which means temporal. My implementation of these will be slower. I see. Oh, I see. Oh, I get it. So since you have motion vectors, you know what's already been processed. So you can just like avoid extra work. I see. I see. I'm kind of wondering. I'm kind of worried that like me just adding mass into the system is just pushing it towards positive like that might actually just be the case. I don't know. Well, this is not good. This is really not good. Here's something. Let's turn off temporal averaging, and let's literally just put v beta to 0 and just have it instantaneous, so that nothing is biased in any certain direction. Just for the testing stuff. Well, we'll run slower. I see. Particle is 1 SPP. I see. I see. So it's kind of like about, you know, about scale, I guess, right? Yeah, that's obviously not working. In fact, that seems worse. That seemed like legitimately just plain worse. So yeah, let's just literally do this, because this is, you know, yeah, it's all I wonder if I need to recenter this around 0. Like, I wonder if this just isn't good enough. Because it's sigma minus dx. And dx could technically be huge, couldn't it? So what was I doing beforehand, before this? I was clamping it, wasn't I? I think I was clamping it between 0 and the clip, wasn't I? This. Okay, so that's first what I think we should do. Just try that out. Because who knows, right? Maybe it's the no, I think it's still, yeah, it still is flowing there. Let me try a sigma of 0.5, because 0.5 should be exactly centered in between 0 and 1. So that should technically always be... It is 0.5, it is. Yeah. Yeah, that's probably not going to help, huh? Yeah. Yeah, I might not be able to figure this out, to be honest. Today. The thing is, this isn't technically centered between 0 and 1, because this is never going to be negative, right? So technically G is always going to be positive, and so us adding G into the system is always going to be injecting stuff, right? The only times where it wouldn't be would be if this was grid and not back, and we just didn't use the growth before now, which this is going to look a lot differently, but I want to see if it's going in the same direction. Yeah, it is. It still is. Okay. Still is going in the same direction. I did change the border, right? I did, right? I think I did. Yeah. And we are a Taurus on everything else, so this wouldn't matter. I wonder if I go to none, if that changes anything. Yeah, I think it is. It's just kind of hard to tell, yeah. It's hard to get any pattern that that proves it. Okay, there you go. There you go. One SPP sample per pixel means there's no noise outside of indirect lighting. One ray for every pixel. Oh, I see. I see. Oh, so that's what it is. Yeah, I had no clue that sample per pixel was SPP. Yeah, that's... I mean, yeah, 1 to 0.1 is pretty nuts, huh? That is pretty crazy. Yeah, I already do this to F. I mean, like, I already center F. I doubt that centering the velocity would do anything. We already did this. The centering the velocity thing. I mean, we could do it again. But I don't think centering the velocity matters, because the velocity is almost always going to wrap around the grid. But yeah, I mean, I guess we could try wrapping the velocity again. So that's what I'm gonna do. Real bummer though. Yeah, I may need to get another coffee today. I am out of it. Yeah, I think we might just be inherently biased, which is like the annoying thing. Like, I mean, I don't think that there's any error with my math, so it's kind of one of these things where I just don't know mathematically how to fix that, you know? I would have to subtract it from somewhere, possibly. I think the only reason it was working earlier was because we had a bug with it. Yeah, that's a bummer. It's important to go back to the thing where if you just have this and fx is always 0, then it works fine. Right, like that'll work just like literally fine. So we won't have any bias if that's 0. So if it's not 0, we have a problem. Yeah, it does help with accumulation, but only to preview. Doesn't blend the colors well. Yeah. Use TAA to make your own upscaler. Yeah, yeah. It's pretty crazy. The jitter stuff was pretty cool to see. Yeah, upscaling is really interesting to me. I have no clue how people do it. I'm really like interested in that actually, to be honest. That has always interested me. So this is 0 and this works. So this would always be 1 1 1 1 1. Right? So when it's not 0, then things break. 1 2 3 4 5 6 7 8 9 10 11 12. 1 2 3 4 5 6 7 8 9 10 11 12. Temporal or higher quality. Yeah, it seems really useful, the temporal stuff. I think like I would kind of want to make my own upscaler thing. That would be pretty fun, I think. Fun project to do. I wonder if this is sometimes going to the wrong coordinate, but I would have no clue how to actually test that. Because that would maybe explain this, how this is problematic at some point. Let's do a test here. Let's test if all of it is 1. And if it's still biased, then we know that it's a problem with... I think it is. It is. And if it's 0, it's not biased at all. Spatial can only work with current frame information. They can't jitter the camera either, so they don't have multiple real samples to work off of. Spatial ones are really just fancy blurs. I see. Right. Yeah. I guess that, you know, you could use it for like still images though, I guess. But yeah. Yeah, I have no clue about the upscaling stuff. Oh yeah, I've heard about FSR being bad, yeah. I've heard about that. I wonder if it's literally just floating point imprecision. Or maybe it's just literally how I'm doing this. But like... if I could guarantee that like half of the time we go -1 instead, like would that solve it? Like if we just did this, and I mean like is that what it is? It's because I'm going positive every time that it's bias positive slightly. Why does this work though? Oh wait, no, it's because it's at 0. It's because it's at 0. This is not it needs the what's the one again? I don't even know. FDMX? Yeah. Or FMX, yeah. Oh, that's pretty bad. Oh, now everything is biased in the other direction. Well, shit. Oh, well. Shit. Man. Okay, well, now I know. Okay. So it's this. Okay, maybe... okay, so maybe we... okay. This is what we'll do. This is what we'll do. I'm just going to do both of them in one. Yeah, I don't know why I didn't think about this earlier. Let's just literally do this. Probably because I'm like super tired today, but let's just pretend like that isn't a thing right now. I'm not tired at all. I'm completely tired. I'm good to drive, you know? Oh shit. Well, this isn't correct, but this, I mean, it's kind of cool. That's kind of cool. Huh. Okay, well that's definitely not correct. Oh wait, no. It'd be +2 basically. It'd be MX +1. Oh no. Oh no. Temporal will get multiple frames. Yeah. I see. Yeah, it's interesting. I guess, like, how does Temporal start out? Like, for the first few frames, does Temporal, like, what does it look like? Does it look, like, low res for, like, the first few frames? Or does it just like have like a some beta or something that this should be the exact same. Yeah. Yeah, this is not correct at all. Plus, it's still going in the positive direction. So, maybe the problem is how I'm calculating this, actually. You know what? I was never very critical of the fact that I do this. I would be really pissed off. I would be really pissed off if that's the problem. I would be really pissed off. I would be so pissed off if that's the problem. Oh man, that would piss me off right now. Nah, yeah, that would really make me upset, actually, if that was the problem. I think that might be the problem, was that I centered it in voxel space, but that inherently pushes us forward in the positive direction. That may have been it. Okay, so we're never doing that shit again, bro. Where we just like trust. I guess I trusted the whole calculation thing, but yeah, never do that. Never do that. Never do that. Not a huge fan of this song. Sort of. Is that? It still seems to be going in that direction, but it's just less obnoxious. Oh no, it went in the other direction once. Okay, well, I think that's probably what it is, so yeah, that's annoying. That is annoying for sure. I get it now. I do get it. Kind of. I mean, us doing that. Okay, so. Okay. That is really frustrating, though. That that we have to subtract again to whatever. Reminds me of the noise scaling errors. Yeah. Suffers from ghosting. Yeah. The ghosting was pretty crazy. I've literally seen that during a trip, yeah. I wonder where the ghosting comes from. Like, I mean, I was reading that article about it, but like, it's gotta be something like natural about the way eyes perceive things, because I've like literally experienced that before, you know? So that was interesting for me when I saw that. Very interesting. Okay, so I think that we can get rid of... Oh, no. Hold on. Oh, yeah. You need this because we're doing the manual modulus stuff. That's the whole point of all of this. Okay. So this is the same. We calculate it. by going inside of the middle of the voxel, but you can never calculate any position based on that offset. We learned the hard way. Okay, what are the fruits of our labor? Okay, well, you know, we did save a lot of stuff by getting rid of the fmodf. We have, you know, we brought it from 0.0, or whatever down to 0.01, so that's pretty good. However, we aren't seeing like anything on the screen, which is pretty concerning, to be honest. So there's also that. There's also this, you know. Should make sure that FMX is. I think it is correct. Yeah. I think it is correct. I think it's just now that that's the correct thing. It may like. It may work a little bit more sketchy. Oh yeah. So we need those. We need those. I got rid of them because I'm stupid. Oh my gosh, I really don't want to. Did I? Okay, no, I have them here. Disregard improper depth. I see. Yeah, I have not done anything in terms of like depth buffer or anything on this project. It is kind of sad that it isn't getting anything now. It's not making anything, which is pretty concerning, to be honest. Like the growth is obviously there and stuff. It's just not doing anything anymore. Which may be an unfortunate consequence of the math that we're doing here. It may be an unfortunate consequence. We use back and not grid, yeah. We do. That is correct. Yeah, everything is just very still. So something else must be going on here that that we need to pay attention to. I think honestly, what we did with clamping is probably killing us. That's probably has to do with it. So we should go back to this. You run a 3x3 neighbor check to get the min and max color difference, then clamp the PR, previous color. I see. I see. But by smearing, are you talking about like something similar to the ghosting effect? Or is it entirely different? Oh, I know what's going on. I know what's going on. When I was like getting pissed off, I set all of these hyperparameters to this because I was annoyed. And so yeah, that probably has something to do with it, right? At least I hope so. Yeah, we're getting stuff now. Yeah, there we go. Okay, sorry. I was almost crashing out there. No, that's exactly the behavior that it should have, because it's the difference between the velocity and the immediate velocity is the displacement. So it having no displacement when I had the velocity set to the immediate velocity is correct. It's 100% correct. I'm kind of interested in why this is going into that direction, though. That is kind of suspicious. Be very unfortunate if I biased it in another direction. Am I aware of why transparent objects don't appear in deferred? I'm not really sure. I'm not entirely sure. We're still going in the same direction, by the way. I cannot catch a break. I cannot catch a break. Is it the oscillator? If it's the oscillator, it's whatever. I don't care, but like, if it's not, I'm gonna be annoyed. Smearing is ghosting? Okay. Got it. Yeah, it's all going in that direction. Very slightly. Big bummer. Big bummer. I thought it wasn't for a second, but it's definitely better now than it was before. But we could try uncentering it completely in terms of this as well. The thing is, mu also needs to get uncentered because mu is also off-center by design. It's centered in the middle of the voxel, so yeah, it's all going to the top right still. Yeah, that's unfortunate. Doesn't happen with most patterns, but as you can see, everything's going to the top right now. Deferred rendering can only apply effects on top. Can't light well behind transparent. So usually for transparency and deferred rendering or forward rendered. I see. I get it. I get it. Interesting. Now, yeah, that makes sense. That does make sense. Because you're basically you know, you're building up the buffer to apply the lighting at the end. You know, it makes sense that forward would be able to apply that easier. You know what I'm realizing actually? Sigma minus dy. dy, it has to be between... There's no guarantee of this being anywhere near each other, right? So even if we uncenter it, it's not even, I don't think it's even a problem of being centered. I think it's the value itself. Is that it's biased to be very, very positive, maybe. But I don't know, I think it's actually the displacement, because once again, if this is just 0, then everything works fine. Or if it's just 1, then everything works fine. Like, it's literally only when this is asymmetrical that it's a problem. So, I don't know. Oh no, that's skewing positive now. Yeah, I mean, I think it's just absolutely the worst. Maybe I was wrong to uncenter it everywhere. Maybe that was a part of the problem, that like I'm not supposed to do it here. Like, don't touch mu, and I don't touch it when we calculate. And I only do it what? Maybe I just leave the bias in here and then just do it here. That's also a possibility. I guess we can try it. I mean, I don't know. Oh, why not? Why not? No, yeah, it's all in that direction. And oh, wait a second. I've F uncentered right now. It's probably not that though. Yeah, it's not that. Yeah, it appears like me force uncentering it like that was really bad. It was a really bad decision. So oh, also, of course I'm not supposed to be doing this, but if I do that, but you know, it is probably the correct decision to do it like this because this is how we're indexing things, and if this is backwards then or biased, then it's a bad thing. But maybe the periodic stuff doesn't matter here. Yeah, I mean, I don't typically write good comments, so I've always struggled with that. Yeah, it's still going to the top right. It's like very slightly so. Yeah. Yeah, I might have to just give this a rest for today because like I'm obviously not getting it, so I don't know. It might be like something like actually just inherent in the way I'm like spreading it out, I guess, you know. It might just be like inherent in the way that I'm spreading things out. Yeah. I think that the weight could just be distributed, you know, poorly using this method, and I would be better off just using like a Gaussian sort of method. I guess we could... No, but it would be the exact same... It would be the exact same sort of thing going on here. But I guess you would go around the cube instead of just inside of it, right? So what it would look like is like yeah, because right now we start at 0, 0 and then end at 1, 1, 1, 1, 1, right? So instead of just surrounding the cube, right? So let's just do the Gaussian thing, I think. I just have to figure out how I'm going to do the weights. Because like here you have the clear thing to split it up. So this method is what I looked up is good for when you have basically a position like this that you need to spread over the spread of like multiple different voxels. The issue is that it's inherently biasing us positive. Which I don't really know what to do about, to be honest. Like, I'm fairly sure even with all of this commented out and just having the regular accumulation, this will still... Oh no, it won't, because I don't have that with it. So it won't skew. But, yeah. I could literally loop us... like that. Yeah, just do that. I mean, like, just out of a proof of concept here, I kind of wonder, like, if I... Yeah, let's just do that. So... Yeah, so let's just calc the position from... It's just going to be mx minus, or plus ddx. Yeah. And this is going to be 8. And this is just going to be the proof of concept because I need to know if it's still biased. No? Yes? Oh my god. What just happened? That's the craziest thing I've ever seen happen. Okay. Yeah, I didn't bounce check it. Yeah. That's true. That is true. I didn't bounce check it. They really got me on that one. My bad. I did not bounce check that that array. Yeah, I was kind of like pissed off, so I was just writing the code without thinking about it. But yeah. That's how it goes on Windows XP. That's how it goes, man. One day you're here and one day you're not. Oh, we're at a different resolution. Oh, that's nice. Well, this is the resolution we're at now, so. Okay, we're gonna not do that this time, and we're going to just, you know, do a little bit of a modulus here. Yeah, I'm sorry, I'm not doing a good job today talking and, you know, whatever, but yeah, it's because I don't really know what to do because, like, you know, it's just like kind of the method we're using to distribute our you know, weights is just biased towards a certain direction, and that's pretty much it. Okay, so if we fuck up now, okay, let's just lock in here. Lock in. Okay. Left operand has type float. No, it doesn't. No, it doesn't. What are you talking about? No, no, it doesn't. Oh. 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 Yeah, that's probably the other reason. That's probably the other reason. That's probably the other reason why we crashed. No. Okay, we need to know, are we still biased? Are we going in the same direction? Come on, come on. Show me the money. Yeah, we're still going in that direction, bro. I'm not gonna lie, we're still going in it. It's not as obvious. But it is, yeah. Maybe I'm just paranoid now. I think I might just be losing it, you know? It'd be fucked up if, like, my kernels that I'm convolutioning with are fucking biased because I wrote that code wrong all that time ago. Okay, show me some movement. There's 8 neighbors, right? 1, 2, 3, 4, 5, 6. Wait. 1, 2. I think we're fine. It's not doing a lot of stuff, but it's not like... No, it's doing it. Do you see this? You see how it's like, you know... The topic itself requires background information? Yeah, it's like... I guess. Okay, so basically, right, all of our shit inside of here has values, okay? And so we derive our velocity from those values, okay? So if we're deriving our velocity and our, you know, positions from those values, then if they skew positive, right, then we're always gonna go in the same direction. So that's the background you need to know. It's kind of fucked up, to be honest, man. Like, it's kind of fucked up, bro. It's kind of fucked up, bro. Like, it might even be that it was always skewed in a certain direction, and I just didn't notice because I was too stupid for a long time. And now that I notice, it's just, you can't kind of unsee it. It might be one of those things, to be honest. Like, I think it might have always been going in a certain direction. Alright, peace out. I should get some coffee, actually. Like, it's hard to tell if we're not doing the velocity-based stuff. Actually, now I think that it's not, actually, when I'm not doing the velocity-based stuff. Yeah, it's not happening now. Yeah, I don't know. Maybe I should be adding the velocity actually, like instead of subtracting it. But, you know, I don't think that that matters. I think it's just fucked, to be honest, but yeah, like this shit is totally going in that direction. Yeah, like, dude, like, look at this shit. Like, I can't believe it. I'm trying to think about, like, the nature of wrapping around something, right? And so, like, if we have a certain velocity that wraps around, right? Maybe it's like, because this velocity gets to be, like, a big number, right? So I think, like, maybe... Hmm. Yeah, it's funny because if you do this, right, then we just go in the other direction. But even with this, then we're still skewed, even if I do it this way, which is really annoying to me considering that it's like this is designed to be even. This has to be even completely. So then, like, how... We could try not wrapping. Just don't wrap it, and then see where that takes us, I guess. Like, if we, instead of wrapping, just, like, literally, like, greater than or equal to grid height, then, 0, then my. Like that, I guess, like, just, like, try that out. Instead of wrapping, we'll just set it to the thing, you know. Yeah, this is not what I thought I was going to be doing today. But I tried to optimize the code, and then we, you know, found a bug, and then we were like, okay, now time to fix the bug, and this is, you know, this is us fixing the bug. Now it's going the opposite direction. Do you see it? Now it's going this way. Oh wait, no, hold on. I'm not even doing the thing. Yeah, this is the thing. This is the thing. Okay. Okay, we don't seem to be biased. Okay, we're going to the bottom left here. We're going to the bottom left. We're getting some strange patterns for sure. Let's see where we're going. Where we're going. We're going to the top right. Still. Like, look at this. Look at this. You can't unsee it. You can't unsee it. It's going to the top right. You cannot unsee this. Okay, but this one's going to the bottom left. This one's really going to the bottom left. What the fuck, bro? Okay, so now you're telling me that it's just, it doesn't matter. It's going in either direction now? The fuck are you talking about, bro? What are you talking about? Why? But why? 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 Man. Nah, bro, like... like, you can't be serious. You're joking. You're joking. You're joking. You're joking. Okay, yeah, this is definitely wrong. Okay, me switching that was definitely wrong. Okay, so we're gonna switch that back. We are gonna switch that back. Man. Okay, so let's try something similar here. Let's try to wrap it with -1. Let's try wrapping it with -1. Maybe that's what it was all along. Technically that shouldn't work, but you gotta give it a shot. You gotta just send it, you know? Made a latte? That's awesome. I don't have the ability to make lattes here, which sucks. But I have like a French press or whatever, which is nice. My coffee is kind of calling to me though, to be completely honest. Yeah, you get these weird patterns here where it's okay, now it's going to the bottom left. Yeah, now it wants to go to the bottom left. Yeah, so wrapping at -1 biases it towards the bottom left, and then not wrapping it at -1 biases it to the top right. I don't know, maybe the whole thing is fucked, to be honest. I don't know. I legitimately have no clue anymore. We don't own a coffee maker? Coffee makers aren't as common. I see. Yeah, I drink a lot of tea myself, yeah. I have a kettle, yeah. But typically, I mean, my use of tea is that like I drink it when like it's either I'm too lazy to make coffee or it's too late to drink coffee. I'm a very big coffee drinker. Now it seems to just be flowing in both directions, so I don't even know what to believe anymore. I've like literally no idea what to believe. I think, to be honest, okay, so here's my big idea. I don't think that my code is wrong. I think that I'm wrong. I think that my velocity based like temporal averaging thing, it naturally biases things to move in the same direction because it's picking up velocity in one direction. So this pattern wants to go to the bottom left because there's velocity, right? And it's the same thing for probably literally anything else. Like this one is going to move to the top right because of velocity. So I think I'm just like really fucking stupid. I think I'm just really fucking stupid. That's what we learned today. I've one English breakfast a day. Coffee I have some days. Yeah. Yeah, I've got like a bunch of different teas. I've got like a chai. My parents for my birthday got me like this fancy loose tea. Um but yeah. This one seems biased to the bottom right. Wait, is everything biased to the bottom right now? If that is the case, then that's bad. Oh, this shit is sick. This one's sick. It's hard to tell with this one. This one looks biased towards the top right, though. Yeah, this one's biased to the top right. Yeah, I think it's just the nature of velocity. Like, maybe I just, like, don't know how my own code works, to be honest. Like, I think that that's the problem, is that I wrote a system that, that uses velocity, and now I'm expecting it to stay still. Which is pretty stupid. It is really stupid. I guess we could like damp it by a lot though. Like we could straight up damp it by like a lot and have like a less aggressive beta. And then probably push the DD up a bit. And then like see if there's like some stability. I think also like having a sigma of like, you know, 1, just like a higher sigma might actually help things a bit. Yeah. Sigma, by the way, is sigma like in most mathematical things. It's like a normalizing factor. Yeah, we may have to come up with something to stop it all from going in the same direction. Because that's what's kind of happening, is that this one's kind of mesmerizing. Yeah, that is kind of cool. Okay. All right, I'm gonna like stop crashing out about this and like move on, I guess. But yeah. It makes sense that it's biased because of the nature of the velocity itself, you know? It makes sense. I don't really know what to do about it though. The Sigma male, yeah. I'm all about that. I'm all about that. I once knew a Sigma male. I don't think about it very often, but I once knew a Sigma male. He was not very pleasant to be around. He was not very pleasant. It was when I went to for the little bit I went to business school, you know. This guy was not fun to be around. He was definitely a Sigma male though, you know. And he like he he would just like make racist jokes all the time and like homophobic jokes all the time. But it's like, man, like I come from, like, I went to school for a bit in the South, you know what I mean, in the southern United States. So like I know like plenty of people growing up that were like that, right? But like they were like funny about it and they didn't care about it, like, you know. This guy cared about it. Like, he was serious. He was like really serious about it. And he like, yeah, he was like, yeah, this guy was, oh my god. I was always so uncomfortable around him, dude. I was so uncomfortable because he would just like, oh man. And then he added me on Instagram, and on Instagram he like had all these like racist memes and stuff. I think he had like a bunch of like Patrick Bateman memes too. Like, he was like the guy. He was the guy. He was the guy. No, yeah. I mean, that guy was bad news. That guy was bad news. Very funny though. Very funny guy. Very painful to be around. Very painful. There was a point in my you know, my time there where like there was no one to hang out with, that, yeah, I did like, oh my god, I remember there was this time that like we got high together and we were just like smoking, and then I got like way too high to the point where like I couldn't like do anything, you know. And so we were walking around and I was just way too high, and he was just glazing himself. He was just glazing himself, like, I mean, like, I don't even remember the conversation that much, but I just remember him like talking about like how he was like going to like change the world and stuff, and how he was like so much smarter than everybody else and stuff. Like genuinely, that was like, that was crazy. That was crazy. Yeah, so everything I do here just seems to make it worse. So there's that. There's that. I wonder if this like this stuff that I'm doing here isn't even working, is it? Yeah, that might have been what it was. I don't know. He had me convinced, you know. He definitely had me convinced of it, you know. But that was like everybody at business school was like exactly the same person. Like, it was kind of like a very depressing environment to be in. Yeah, this is definitely... I wonder if like I wonder if I tried forcing velocity to change every once in a while, if that would help things, but I don't know. I hope that it wasn't something else that I refactored today and I just like totally forgot about it, but I don't think it is, because it's going to negative, 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 and positive, positive, positive. So that means that it's just, you know, it might just be the nature of the velocity itself. Like if I, for example, so this is what we can do. We can just like literally base it off of F and then just see how this, you know, how this looks like. Some racist guy I know that got rid of. Yeah, I got rid of? Like you you like what do you mean you got rid of him? like like you got rid of him? Like yeah. Yeah. Oh my god, that's crazy. That's crazy. But I mean, that's how people are, though. That's just the way it is. Like, people are always like that. That like they just put up a front, you know. I'm the same way. That's, you know, I secretly love JavaScript. Just kidding, but yeah, it's always going in a certain direction, isn't it? It's like all diagonal. I do get slow always good night. Exactly. Yeah, it's all diagonally in strata. Even with just using raw F here. So yeah, there was that. You write everything with fixed typed arrays, it becomes pretty close to C. Yeah, I'm sure it's not bad. I'm like, yeah, I'm 100% sure it's not bad. It's not a bad language. I just like making fun of it. You know what I mean? Because like, I don't know. It's like JavaScript. I like making fun of it because I have like I hated myself when I programmed JavaScript. Yeah, I mean that's just people, man. Okay, so this just breaks everything. So I should not do what I just did, which is take 0.5f off of there. Oh, actually, you can take 0.5f off of there, and then just like literally don't subtract it twice. Like I subtract it twice down here. Like here. Maybe me taking off of like the inherent bias of the mu array and the pos array will just immediately fix everything. I don't know. At this point, I'm just hoping anything works so that I don't have to I can do this anymore. This is getting ridiculous. Okay. Okay, hold on. Hold on. Okay, 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 okay. Nah, see that shit is diagonal. Okay, I feel like it's better though. Yeah, I never make fun of people for what they can't control, you know? That's just you know, that's a given. Okay, I think it's not I think it's going in both different both directions. So yeah, like this one is heading to the top right. It's just kind of annoying how some are positive and some are just straight negative, you know? Like it's kind of annoying, to be honest. But maybe that's just the nature of the math that I did with the velocity stuff and not like... Yeah, but it's that's not a joke. That's my livelihood you're talking about right now. Yeah. Yeah, I mean, what can you do, right? Like, I guess, I don't know. Like, I made it so that velocity accumulates, you know? So I should not be surprised when everything starts going in the same direction. I shouldn't, but... Yeah, I don't know how I'm gonna handle it, though. It was kind of covered up before by the bug, and now it's kind of very obvious to me. Like there, that's really obvious. What I'm working on is the 3D volume of noise. It started off as like me trying to bring this like 2D simulation into 3D, and now I've kind of like started to like make my own math with it. There's no like clear idea of what it is. I basically just want to make like a real cool like 3D kind of world generation thing, like where you can just like walk around and like look at the patterns and shit. I think that it's like just mad cool, you know, because I know I'm just pressing the random button a lot, right? But you can like take the panel out, right, and start like moving stuff around, and I think that that's just mad cool, you know. Perlin noise cave generation. They have cave generation for Perlin noise. That's crazy. It is kind of like noise, right? But there are some patterns that are just like very, very neat. It depends on the parameters, right? But yeah. All Minecraft uses it, yeah. I do like just like sitting here and watching the patterns, you know? It's kind of like what I always wanted to make, was just like something real cool to look at, you know? So yeah. It is a bummer, though, about the other shit. With the thing. Yeah, I mean, I haven't like, honestly, Honestly, I haven't like met a lot of like people like that, like outside of like business school. To be honest, it's like the only worst part about it. To be honest, yeah, I think so. The difference between what they do, which is they like go basically just in a circle around here and then just like recalculate this for everything around it. Um, what we're doing is more intentional because we are basically taking our velocity and then going to the voxel that it points to and then spreading it out, right? And so I think the effect that that has is just like us basically pushing in a certain direction, and then we slowly make the whole entire displacement in. Yeah. Yeah. That's what I'm talking about. High quality terrain generators, yeah. Yeah, well, the terrain generation stuff kind of blows my mind, you know? For sure. I think maybe I'm going about this wrong. Yeah, hold on a second. I have an idea. I have an idea. What if we just add it to uh what if we just add it to SRC? And just go in a circle around SRC and then just do this. But hold on. Let's test this out for a second. So this would not be x0. We would have to find the difference between us and this and the mx. Yeah. And ray tracing, they can be made so fast because they're a simple primitive. Oh, that's sick. Yeah, I don't know anything about voxel ray tracing. Just the regular voxels, you know. I think it's actually going to be a, yeah. So it'll be an integer since. No, it always no. You're just trying to get the weights. Maybe it's just 0 then. Disengage my ray tracer because it has to resort all the entities when you make new ones. Where is down when you add tons of objects? I don't know what you mean there. I'm not sure what you mean there. Maybe we have it just perfect. Yeah, actually, I don't think that we can do what we're trying to do. Really, like that. I think, yeah, I think maybe we're just going about this the wrong way. Like here, we take the R position minus the mu. And then here we're just taking the velocity's position minus the mu. And then this doesn't actually give us the displacement, it just gives us the difference between that and that. Okay, so maybe resort. Oh, I see. I see. I see. Got it. Yeah, that's a lot of resorting then. That is a lot. So we have the position minus the displacement. And that works fine because it's a position minus a position. But here we're doing a position minus a position, but the velocity. This gives us a vector from our current position to the proposed. And then this gives us... Okay, got it. Okay, so a couple ways we could go about this. I'm almost interested to see what would happen if we just literally... I think we used to do this. I think I literally just did this before with MIDX. Which is basically just adding it straight into the one cell that we're going to. But yeah, I think that, like, seriously, it's a problem inherent with the math that I'm doing. I think what I might have to do is, instead of just, like, doing the raw addition, what I should probably do is, are we still... Yeah, we are still going to the right and to the bottom, yeah. Because we're adding the raw thing rather than actually trying to move the mass. We're basically just like letting mass move wherever in my equation, which sounds cool on paper, but in practice is just everything is organizing itself into platforms. Oh, this is cool. My rasterizer has the render handle, so it doesn't duplicate objects in memory. Yeah, I love the vertex lighting. I've done a lot of that. It's kind of like my favorite lighting stuff. Because it just looks really nice. And it's been around for so long, you know? I should do more lighting stuff in this little thing. I mean, I could definitely do... I don't know how the shader stuff works, but... Yeah, so it's my calculation here. This should be... Yeah, we can't just add it straight. I think that my idea might actually just be bad, and I might have to change this. I think my idea might just be bad. I think that that's the conclusion we're coming to. So what we could do instead, though, we can still use V. V just replaces F here. It just completely replaces F in the mu calculation. I think we might segfault though. No? We immediately start moving into that those patterns. Oh yeah, I had this on, that's why. Yeah. I just want to see if this is... We don't get an insane amount of movement, and the reason why is because of, you know, velocity is less less powerful than the pure F. Yeah, not a lot of stuff going on. But if we replace F with V, like this, we get some interesting things happening for sure, but that's kind of cool. You get a lot of still patterns like this. Anyway, so if we want to use V instead of F, that's how it's got to be. And so instead of having all of this stuff, I think we literally have to do the roll. Voxel reflection progrid. Yeah, that sounds awesome. So you're gonna have all these are these gonna be like 3D textures or just like some sort of indexing system? So I think we're just literally going back to, I think we've come full circle now, and we're just gonna go back to looping over the. Yeah, it kind of sucks. I don't want to do that, to be honest. Like, if I have this, how do I spread this out, like, Gaussian? It doesn't have to be Gaussian, but like... Yeah, let's just... Actually, yeah. So let's just literally do a Gaussian kernel. It'll be way less expensive than... Yeah, so let's just literally do that. So... I literally have this down here. I mean, I probably that's probably, yeah, I guess. Index 3D textures. Rasterized voxelation. Probe draws still do 6. I never did any lighting probe stuff, so I have no clue. No clue about any of that stuff. So this isn't going to be SRC. This is going to be. How do I do this again? Hold on. Oh, wait. Yeah, so you can't have this. It's just going to be this, and then you multiply that times it, and then you are adding it. No. No, it is. It is cells SRC. Yeah, it is this. It's SRC. Is getting added into the neighbors. Yeah. That's exactly what's happening. Now how do I do this again with the I plan to have the volumes to a set step size to light the area. Oh, that's cool. Yeah, I think that's how most people do it with like the step size through the volume. I'll try to find the formula again. Yeah, so it's the distance squared over 2 sigma squared. Okay, yeah, that's what I remember. Okay, so I need to get the dis squared. How do I do that in the most efficient way? I've done this like a million times, but I always forget how to do it. Hey Caesar, not much. I'm just like doing some. I have to make a Gaussian kernel to basically spread out the weight of this mass right now. So that's what I'm doing. Probe handler class doesn't place probes away from the root nodes. Yeah. Sorry, I'm thinking about this. Yeah, that sounds pretty cool though. Yeah, don't you just isn't it this though? It's this to the power of 2 now. Or is it, that's actually equivalent to this, so that's why you just do this. Yeah. This is gonna be, we can just use the same sigma that we already have been using. There. Okay. Or maybe you're not supposed to do it this way. I don't really remember if that's equivalent. But yeah, we'll just pretend like it is. Need new switches. Might go linear. Yeah, I'm a big fan of like the tactile switches, to be honest. I don't think I've ever like, I built a linear board once, but I really didn't like it. Okay. So this G will just be that then. Yeah. What's the function name? I already forgotten. It's calcpause. Yeah, sorry, I'm just super tired today. There's gonna be x minus x plus ddx, y plus ddy, z plus ddz. Okay, I mean, like, I have no clue. But just fucking send it, I guess. I don't know. Oh, whoops. Oh, I didn't. Oh, we're really we're glad that I didn't segbolt at that time. I just did the same exact thing that I already did before. That gave us some grief. Okay. Okay. Okay, so we're really slow is the first thing we have to notice. Is that we are really, 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 really slow. And then the second thing is that we suck. So there's two levels there for sure of what's going on. Maybe I did do this wrong. I don't think so, though. Oh, maybe this is going to work. Maybe it just isn't going to work. Yeah, I think that this... Yeah. Project is so big, I end up having multiple features. Yeah. Yeah, that's how it is. That is how it is. Yeah, I don't think that I was wrong here. I think that it is this, but like... It shouldn't be bad like it is right now, so that's something else entirely. That is something else entirely. Oh wait, isn't this supposed to be... Yeah, what am I... Don't I have to... Isn't this... Yeah, what the fuck is wrong with me? Yeah, don't even talk to me. Don't even talk to me right now. Don't even talk to me right now. Okay. So this is a failure, like me. I mean, I doubt that the sigma is the problem. I mean, actually, it might be because the sigma is 0. Is like over 1 right now. So. Okay, I mean, like, I did kind of just expect this to work. Like, you know, I didn't really expect it to give me that much trouble. Like, if I just added raw in, do we get anything? No. No, we don't. Okay, well, I mean, like, like, why is this problematic for me? I feel like. Like, that just works fine. Let me see what the weight is, usually. Why am I number one? I don't know. Not a lot of people want to watch this. It's like not very fun. Which is pretty fair. Yeah, that's a big weight. That's a pretty big weight. Yeah, you gotta keep it a buck there. That's a pretty big weight. That's a pretty big weight. That's pretty big. Wait, but like, hold on a second. Hold on a second. Am I... Wait, what? Oh, wait. It's it's negative inside of here, I think. But that still shouldn't. Maybe the sigma is supposed to be 1? I don't really remember, to be honest, but I thought that it was fine to not be 1. Okay, yeah, that's what it is. Okay, so don't put sigma to don't do that to your sigma, man. The sigma does not need to be treated like that. Okay, but okay, maybe Gaussian isn't the way to go. Maybe Gaussian is not the way to go. Maybe Gaussian just isn't the way to go. I mean, you could also just do this, but like then it's too much. Like, let me see. Hold on. It's release. It's release. Okay, so let me So this is 0.22 when -1, everything -1. Yeah, yeah. I'm right there with you. Okay. Okay, so we're at 0.6 in the center. We're at 0.6 in the center. Sigmas don't wipe. Yeah, you're telling me. I'm 100% right there with you. Oh wait, hold on. We're still in debug mode. Dude, like making a Gaussian kernel has never been so difficult. Okay, we're in Gaussian land. We got some Gaussian going on. Okay. Okay, but so one does have to wonder like exactly what I was thinking with the velocity stuff, because I think that's honestly, I think it just sucks. I think it just sucks, to be honest. What? By the way, this is like what regular flow linear looks like. It looks like this. Kind of. Just like kind of boring. That's crazy. That is crazy. Yeah, maybe Gaussian just doesn't work. Maybe this is the Gaussian experience. That is wild. That is wild. I'm telling you. That is, I've seen them do that. I've seen them do that. I'm gonna 100% agree with you on that one, because I've seen them do that in front of my very own eyes. Yeah, totally, I've seen them do it. What did I fuck up to deserve this? What did I fuck up to deserve this? What did I fuck up to deserve this now? Okay, lock in. I don't know. I'm not even using velocity right now. I'm just using F. And so that's why it's pretty strange why things look so weird. So I probably like fucked something up pretty bad. This should be fine. This should be absolutely fine for me to have. This is what we literally started with, was this. So unless me changing the hyperparameters down here change something. Okay, yeah. We're still yeah, this is fine still. It's just it's less noisy than it was before. Probably because of like just the offsets and the normalization that we did. Yeah. Yeah, I have a lot of warnings too. Really? I really like the N, but that's just me. I'm kind of wondering why we're just like pretty much single channeled right now, but I don't know. It doesn't seem completely broken. It does seem a lot less lively than it was before though. Okay, so now can we please put the put this back on and then like just live a happy life? That would be great. Okay. Okay, okay. I'm with you. Okay. We have waves. But do we have anything like you know, okay, we have some stuff going on. We definitely we do. It is slow as shit. I'm gonna be real. Yeah, I get a lot of warnings as well. A lot. Trust me, when I went to do like my final make file, you know, to and I set it to STD C11 or whatever, and then it's like it like literally just like does not compile, and then I have to like spend like hours using like sprintfs instead of sprintf. Like, dude, bro, listen, I don't care if somebody hacks my program. I don't give a shit about I don't like none of my passwords are going to get leaked. I don't care if somebody hacks my like what? This function is unsafe. Yeah, unsafe for like people who have like money. Hello, can I suggest good OpenGL? I think the website is pretty good, to be honest. I didn't really learn from a book or from anything. I just like kind of did it. So I want to go back to doing V in the thing in Mu, because that's the whole point of the stream, is for me to use V today. That was kind of the whole point. Yeah, I mean, yeah, that's kind of a bummer, huh? The issue with V is that it's biased towards 0 because of it's kind of what? I didn't say that. It's kind of a bummer. A bummer. Because V is biased towards 0 in the, you know, machine learning sense of the moving average stuff, that it's just biased towards zero. So unfortunately it's just going to kill everything if we use V in this manner, which sucks. Yeah. So we gotta find some other way to use it, rather than just putting it straight into mu. We can't just put V here, unfortunately. I wish that we could, but we can't. Yeah, you kind of wonder if it's just like literally faster for us to just do this in here for that, but I don't know. Yeah, did you hear that Obama said that there's aliens? That was wild. That was wild. That was fucking crazy. That was crazy. Your cat? Yeah, my cat is a jerk, dude. My cat wakes up like really early and just like wakes everybody up. He's just like at 5 a.m. He's like not a nice guy. He's a really bad guy, actually. You know what we could do? We could use MU and then see how aligned it is with yeah, so we can get D, which is like the dot product of them, right? And then that should tell us how aligned we are, so that we can scale this based on how aligned our velocity is with our mu. So that's what I'm going to attempt to do here. If I know what I'm doing at all, which I don't. We have to multiply it times time step as well. Yeah. Like that. Yeah, you probably should, you know. I mean, listen, you aren't writing Rust, so you don't have to do anything. I'm not gonna be mad at you. Unsafe use of type bool. Unsafe use of type bool. My bad. I'll just use an integer. Like what? Like what? Do you know I have like 20 warnings whenever I compile this? It's like mad at me for the dumbest shit. Actually, like, yeah, let's legitimately just read them. Okay, it's embarrassed that it has warnings, and now it's just pretending like it doesn't have warnings. Okay. Conversion from int to float, possible loss of data. We have this 4 times. We have k some unreferenced local variable. Oh, my bad. My bad. I didn't use it. Fucking, like... Then we got 4 more conversions. We got 5 more. Okay. D, undeclared identifier. That's what I just did to get this. And then just a bunch of more conversions. Okay, like... It's literally just mad at me for not explicitly casting. It's like... Possible loss of data. The check is not sizing. Yeah, exactly. Like, it's like... I don't know, man. It's like... I don't know. Like, it should not give you a warning if I'm implicitly casting something. Like, why are you reminding me that a float and an int are different things? Like, no shit, man. Like, possible loss of data. Like... Yeah, man, that's the point. That's the point. Oh, man. Okay. Okay, so now we need to dot. Do I have a vec3 dot? Of course I don't. Why would I have a vec3 dot? Okay. We're just gonna do it by hand because I'm, like, really good. Just checking if the int value returned of size. Oh. Yeah. Yeah, it's not the best. It really is not the best. Hold on a second. Shit. I think you have to normalize them first to get it within 0 and 1, right? Shit. Oh, this is gonna be more expensive than you would think, actually. Yeah, let's do this for V as well. Encasing the statement. Yeah, exactly. Yeah, that's the classic. You gotta put parentheses around it. Yeah, it's like... Yeah, it's just whatever. I mean, there's probably a reason for it, right? Like, you know, but like... I don't know. It compiles and runs anyway, right? So, like, if it compiles and runs anyway, and it's just like a syntax thing that you want me to do, like, just shut up, you know? This project is probably gonna end up with more episodes than Friends. I don't really know about that one, dude. I don't really know about that one. So now D, if it's greater than 0, it's going to be aligned, right? The problem is... I kind of want it from the range of 0 to 1 instead of -1 to 1, right? And so you really just... Okay, so if D is in the range from -1 to 1... Wait, is it? Yeah, it is. It is. It 100% is. I'm just being stupid. Okay, so if D... So you want to go... You want to go +2? No. No, you don't. What are you talking about? +1 divided by 2. Yeah. Yeah. I'm right with you on that one. So now we're in the range from 0 to 1, okay? And now we're just gonna multiply this shit times this. And now it's scaled by being aligned with the velocity. There you go. What? VY undeclared identifier. You're an undeclared identifier. Still highlights. Yeah, it loves warning you when you don't need to be warned, and then not warning you when you do need to be warned. That's very true. We're biased in a certain direction. I do hate how everything is blobs right now. Like, everything is circular. That's kind of, like, sucky. Not gonna lie. Also, things just suddenly die sometimes. I'm assuming it has something to do with the velocity thing. The empty method should be used to check for emptiness instead of size. Then why does it exist? Can you tell me that? Yeah, it is pretty laggy, not gonna lie. One does kind of wonder if it would literally just be faster to just put all of this shit in there. And probably not, man. EXP can't be fast, is the thing. There's just no way that that's fast. So one does kind of wonder about the implications. Also, what, Rob? Do you not want this to have more episodes than Friends? What, you got a problem with that? What, you want this show to be over? Is that what you're saying? That's crazy. That's crazy that you would say that. So the funny thing is, like, even after all of this, it is biasing everything in a certain direction. Even though we're just dotting with it, it's still doing that. Yeah, fucking GCC complaining to me that I'm not using sprintfs when I don't wear a tie every day is fucking... I feel even more sorry for you. What are you talking about? Are you okay, man? Bro, are you gonna like crack, dude? What are you I feel even more sorry for you. That is a crazy thing to say. What the fuck are you talking about, bro? That is crazy. That is crazy. That is some Joker shit right there, bro. That is some Joker shit, bro. Jesus. Chill, bro. Chill. Fucking God, bro. He really is really on his Joker arc, bro. I mean, so this is working. It's just I think multiplying times D is kind of like, I don't know. Maybe we want to actually like, what if we divide it by 4? Let's divide it by 4 and then add 0.5f. It's hard to read, but I'm not sure why the compiler thinks it's unsafe. There probably is a reason for it, but it's probably like one of these reasons, like, you know, there's some like you can hack it and then have a buffer overflow or some shit. CRT secure, no warnings. That's a crazy hack right there. I don't know why things just die every now and again here. Like everything just dies all of a sudden sometimes. I think it's my dotting thing that's going wrong, but like also like I just don't want to admit it, to be honest. Don't even get me started on all the warnings for don't even get me started on the warnings for like casting an integer to an enum. Bro, like there's like 10 different warnings I get whenever I try to cast to an enum. It's like the most annoying thing ever. That's the one thing, like if I was to ever make a language, I would make it so that you could just cast to an enum and like not have a problem. I'm gonna suffer every day. I'm doing completely fine. So it is the dotting. I also think that this looks like shit compared to what we had. I'm just gonna keep it a buck, bro. Like I think that this is just what we're doing here is just it just ain't really like what it's all about, you know? It really looks kind of boring. Not gonna lie. Which was kind of like the whole point of what we had beforehand with this, was that it looked fucking cool as shit, you know? And now it's just like boring because I did a Gaussian kernel over it. See, this is sick, bro. This shit is cool, bro. But then you throw a Gaussian kernel over it, you know, and it's no longer cool, you know? I mean, it is kind of cool, but I'm trying to think, like, if I changed anything that would... Because this also doesn't really look like it did earlier, to be honest. So I think I kind of messed with something that I shouldn't have at some point. While we were like, you know, getting pissed about the whole, you know, everything going in one direction thing. I think I probably like messed with something and now fuck something up. I literally don't understand what this project even does. Yeah, but that's the best part. It does a bunch of shit. It does like kernel convolution, you know, it does, you know, velocity accumulation for, you know, cells in a grid, bro. The compiler is right. This is such a non-issue. Use it in place back instead of pushback. Yeah, I can't relate. I don't use vectors. Can't relate. Cannot relate. Cannot relate on that one. I just ain't about that vector life, you know? Oh, did I turn this on? I did. Everybody wants me to make something, man. But what if I just make something that's a whole bunch of nothing? Ever thought about that? What if I just want to make a bunch of bullshit, huh? Got a problem with that? Yeah, that's kind of neat. The size T to int ones, yeah. I'm totally with you on that. There, like, I had, you know, in my engine, I had some things that were size T and some things that were int, and whenever those things come into contact, it was not good. It was not good. Not that there would be any bugs, it was just like the compiler was just like, oh my god, oh my god, oh my god, did you know that a size T is not an integer? Did you know? Did you know? Did you know? And it's like, yeah, dude. Yeah, nobody wants to sit here and cast size T to ints. No one wants to do that. I do not want to do that. That sounds like the opposite of what I want to do, actually. Yeah, like, what if I just do this? So if I do divided by 2, so plus 1 divided by 2 divided by 4, so it would be 2 divided by 4. Okay, so that works. Yeah, I mean, like, I don't know if this idea is good or not, but maybe I'm just like too stupid to figure out if it's good or not. I did try my best with it, though. I did try my best. Also, this is getting, you gotta kind of make sure that this is getting centered correctly, because if not, then that's pretty bad news. Oh, the Cherno, bro. The Cherno, bro. The Cherno. The Cherno is crazy. The Cherno, bro. Oh, really? I didn't even know he was Australian. Or I probably did know that he was Australian, but it never, like, occurred to me consciously that that dude is Australian, you know what I mean? But I guess he is Australian. Didn't he make a video, like, recently? It came into my recommended, like, he was like, I'm quitting, or some shit. No, I'm 100% serious. That came into my recommended. It was like, I'm quitting YouTube or some shit. Okay, bro. Sure you are. Like, what? Okay, bro. I feel like every big YouTuber has to have an I'm quitting video, like, once during their life, you know? I gotta lock in, bro. What am I doing? Plus 1 divided by 2. Yeah. Yeah. This is actually correct. Some videos of him from 15 years ago. in East Melbourne. Yeah, he's the Cherno, bro. Could run into the Cherno himself. I don't know, that dude cracks me up. That dude cracks me up. I can't lie. My nightmare is that the Cherno sees my code one day. He would have a fucking heart attack, bro. Oh man. Oh man. He would not be okay, dude. If he saw my code, holy shit. Holy shit, he would roast the hell out of me. I don't really watch his videos because he kind of gives me bad vibes. I don't want to be like a dick, but he kind of does. But like, when I have seen his videos, dude, like, people send in their code and he just absolutely shits on them, man. It's like, bro, it's like the craziest thing. It's literally Gordon Ramsay. It's literally Gordon Ramsay. It's literally. Oh man. I just couldn't do that, you know what I mean? Like I could not do that as a person. Like I just could not like bring myself to just like absolutely just like go to town on someone like he does, bro. It's like just I could never do that, bro. That's just not a skill I have. I feel like this isn't working. What I'm doing here is not working. I really, you know. Is this guy called Threat Initiative? Perfect pep. Yeah, I don't hate the journal. I don't like hate like really any like influencer. I just think I don't know. It's just crazy. Like I would never like think like, oh man, let me just send my code in to this guy so that he can, you know, rail at me, bro. Like maybe I just don't have a psyche that's just strong enough to take that, you know. I just don't think I'm just not. It's not possible for me, you know what I mean? It's just not possible. Yeah, the problem is, bro, like let me look at the original. So I have a backup somewhere. Yeah, I have a backup. I got a backup in here. I got a backup in here of like what it looked like beforehand so that I can reference it now. Yeah, this code it was a crazy place to be in. So it was up here. You do this beforehand. You do that beforehand, so it would basically be the equivalent of having all of this inside of here, and then this gets to be the thing. It's actually backwards, so this is actually going to be destination now. It always should have been destination, but yeah. It's the worst feeling of all time, though. Putting this, like, this is going to be like the slowest code in existence. So basically going back to what we had before, we basically just like reverse engineered everything that I had before. We have to roll this. It's literally just this. Yeah, that guy sounds crazy. That guy that you're talking about sounds crazy. Yeah, like if he saw what I was doing right now, he would not be okay with it. Okay, at least we don't have to do the Gaussian shit anymore. We don't have to do that anymore. We actually go just straight into this destination, and then we just it's just this actually, and this times D. Oh, yeah, but it's gonna run like shit. It's gonna run like shit. Left of what? Wait, hold on a second. Are you reading from the other from the other file now? 998. What? Literally, it just put all of this code in a body bag. Why are you reading that? Why are you reading that? So see, undeclared identifier. It's declared, bro. It's so declared. Oh. My bad. Ah, shit. Ah, shit. Ah, shit. Wait. Wait, fuck. We could just, yeah. Yeah. No doubt. DDZ redefinition, different types. Yo? Wait, what? Oh shit. Oh, my bad. My bad, bro. You need a better IDE. Oh yeah, you want to write me one? Oh my god, this is so laggy. Oh my god, I regret everything. Holy shit. Yeah, I feel like we don't need to do this. Yeah. Yeah, this shit really got derailed, huh? Yeah, I feel like, to be honest, even if we did get this to look good, it's just so laggy that it just ain't worth it, man. It just ain't worth it. It just ain't worth it. This ain't worth it. Size T to hint. It's fucking raw. Yeah, he would be like that. Oh shit, that's kind of cool. It's like it's little little rectangles. Remind me of Rob. Implicit cast, you twat. It's fucking raw. Dude, I used to watch that Kitchen Nightmares shit all the time, bro. Oh, this is neat. Yo, look at this, Rob. Okay, but come on, Rob. Come on, that's pretty sick. Even you gotta admit it. That's pretty cool. Listen, hey, come on, come on. Say it, say it, say it with me. That's pretty cool. That's pretty cool. Yeah, Mr. Dustmite, that's pretty cool. A little, shit looks like a Dr. Seuss book. You know? Make a good cloud model? Wait, what? Very cool. Like the, you know, the shit in Dark Souls? Very good. Dude, I miss Dark Souls. We're never gonna have another good, like, Dark Souls, you know what I mean? I don't mean to be a hater, but, like, Elden Ring is not a Dark Souls game. I hate to say it. I really hate to say it. I'm not an Elden Ring guy. But I mean, I'm like kind of like a Dark Souls, you know, purist sort of guy, so seems like nothing has any sort of movement, bro. Okay, never mind. This has some sort of movement. Very good. I like not operator? Oh, you're a dick. Oh, right. My bad. Okay. Yeah. I can only hope in agentic IDs I can gaslight the AI compiler. Act like so. Dude, that would be sick. To be okay, so I'm not an AI guy. Okay, I'm really not. But it would be sick if I had a compiler that I could talk to, right? And be like, hey man, listen, can you just shut the fuck up? Or like, you know, like give him like solid feedback on like, you know, what I got going on, you know what I mean? Like that would be kind of sick. So yeah, so like you know. Okay, so what did we do wrong? That's what we gotta ask. So this is X. Wait, hold on a second. What? Oh shit, my bad. Oh shit, my bad. We were using the wrong thing. We're not. Oh wait, no. No, we are using. No. We're supposed to use destination, bro. We're supposed to be using destination, bro. SRC. Yeah. Yeah, no doubt. Sigma? Okay. Yeah, that's not cool. That is not cool. Tell the compiler that's not cool. Okay. So what you're telling me is that we've lost the ability to find cool shit. That's what you're telling me. Aw, bro, but like... Mass conservation is so not cool, bro. This is the problem with mass conservation. This is what they don't tell you about mass conservation. Is that there's no mass anymore. There's no mass. Okay, there's some mass, but it dies. I just killed it. It's what they don't tell you about mass. The mass problem is unbelievable. The mass situation is unbelievable. Who ate all the mass? I don't know, bro. To be honest, I blame fucking Rob. That guy said it wasn't cool, and then it became not cool immediately after he fucking said that. So fuck that guy. Yeah. See, now it's all tiny, man. Oh my god. Okay, so by the way, what we're doing now mathematically is we're doing what is, you know, supposed to happen in Flowlenia, which is we are accumulating from neighbors, okay? We gave up on the velocity thing. Well, we didn't give up on the velocity thing. We're still doing the velocity thing, but it's in a different manner. You know? You know what I'm like a big fan of? I think like Tomb Raider is fucking awesome, dude. Am I the only one, man? Like, Tomb Raider is sick, dude. Tomb Raider is fucking sick. Huge Tomb Raider fan. Huge, huge. It has a nice HDR implementation. I was talking about like the old, you know, Tomb Raiders. There were PS1 games, right? I think they also came out on PC. Dude, Tomb Raider 2 is that fucking game. Oh yeah, I played the 2013 one too. I had it on PS3 when it came out. Yeah, my parents got that one for me because I was such a big Tomb Raider fan. Yeah. I got the fucking my dad got like the collector's edition or whatever with the tin or whatever. So I have that. I think I played the 2015 one. I didn't really like it that much. You should really try out the old games. They have a remaster for it. Yeah, it seems like the growth is good. It's just like nothing is really living is the problem. So nothing is really living. Wait, what did I? Yeah, so that's correct. Yeah. Okay, well, you kind of wish that you could do 222, but you can't. 3. Literally trying so hard to figure out what this project is even showing. It's showing something cool that only cool people would be able to figure out. So, unfortunately, I can't really explain it. But, you know, it sucks. I can't explain it, but like, it's just not for some people, you know. It's esoteric like that, you know. It's just not Some people get it, some people won't, you know? It's alright. It's alright. Okay. I think that, honestly, I think that we should just move this shit, some of this shit into the UI that I was planning on doing was like the whole point of this, to be honest, was putting stuff in the UI. Yeah. It kind of sucks, this stuff, but what can you do? Oh yeah, we could try actually this. I mean, it might do something interesting if we don't have normalization anymore, or have less normalization. Okay, so you know what that lag is? That lag is us doing the vector normalizing. So yeah, apparently we can't do that. So I think it's a neat idea to check if our velocity is aligned with our, you know, but apparently it's not going to allow us to do that, so. Dude, do you know how many times my thing compiles in debug and then it doesn't work? So, you know, people use realistic ways, yeah. Yeah. It's actually a big part of the math that's going on here is the same sort of thing. Pretty sure you're not that cool guy either. Okay, Rob. Okay, Rob. Okay, buddy. Okay, buddy. Guy made one macro and he thinks he's that fucking guy. You are not that guy. You are not that guy. You are not that guy. You're not that guy. You're not that guy. You made a macro. Okay, bro, you're not that guy. You are not that guy. Nah, it's bad when it works in release and not debug, because then yeah, without normalization it just doesn't work anymore. Maybe that means that we did it good now. Okay. Basically, what this is it's interpolating between two different types of normalization. Okay. Kind of cool. But the mass is conserved, so everything dies. The physicists love it when everything dies. That's what they love to see. But like, look, if that lived for long enough, that would have been sick. That's the problem with this, is that like, now everything dies out because now we have like proper mass conservation. God, it sucks. It sucks that I can't push this harder. Like, I wish I could like have the velocity being aligned with the, you know, the other shit, but it's like, it's just so hard on this computer. Yeah. It might also have something to do with the yeah, let's try touching the temporal averaging stuff. If it weren't for your macro, dude. Dude, we aren't even using that code, dickhead. That didn't even make it into the final cut. The Sims code didn't work, so... I feel like I would go pretty ham. But I mean, like, I did choose to do this on Windows XP, so it is kind of like my fault. No, yeah, that sim code didn't even work, so we didn't even use it. So, you're like, you know that meme of that guy like talking to the wall right now? That's you right now. Bro is behind in the lore. Bro did not get the memo. Okay, maybe fucking Christ, dude. Like the amount of times I've like gone back and forth on this. Is ridiculous. There, I finished my sentence. What, you thought I wasn't gonna finish it? No, I finished it. I finished that shit. The problem is that you can't actually get drivers for those cards. It's kind of the problem for Windows XP. Unless you want to make it yourself, which would be pretty hardcore. That would be pretty crazy. Yeah, it feels really noisy now. The problem is that this is what Lenia looks like, is it's like a lot of this, and then occasionally you get really cool shit, when before we were getting cool shit all the time, but because it was buggy. Yeah, so that's pretty cool, but then it dies out. Because of the math that we just did, so. It does suck to see everything die out like that. What are we mad at? Literally, like, what? Oh. Oh, that's gonna be a problem. Wait, no it isn't. Oh, is this a problem? No, I wasn't. Yeah, I wasn't cool enough to use the macro. I was not. Oh, it's down here. 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 Yo, like... Bro, like, what? Oh. Yeah, that is a beast. That would be a beast, though. That would. I think we may have slightly over-engineered it. just to shit on what I'm capable of. I mean, like, what would you do with that thing, though? Like, what would the use case be? Playing like fucking Splinter Cell at like 3 million FPS? That's a pretty good use case, but yeah. Mud Simulator? Yeah, that sounds like Rob Simulator to me. Is that what wait, you're calling this a mud simulator? Like, sure, bro. I actually use velocity for this. Actually straight up use velocity for that. Factual. Yeah, I don't know, man. I kind of feel like we should just like go back and destroy everything that we did today. I'm like gonna keep it 100% with you. Like, I just feel like, to be honest, it's just not doing what it should be doing. You know what I mean? Unless I did something wrong in the formula, no? You know what, actually, oh, yeah. So, hold on a second. Okay, there is something that we can try here to like, salvage things. So, technically, the only difference between us and them is that they don't have a growth function, right? And we thought that growth functions are cool, and we wanted a growth function. So this is what they have. This should be equivalent to what they have now, without the growth function in it. Yeah, seems about right. Seems about right to me. Yeah, that's a lot of fun, bro. See, like, this just ain't it, bro. That just ain't it. What they would want you to do, right, if you're to do this like the physically accurate way, is to apply the growth function here. What you would do is you would go plus cells I dot h c times time step, and then that would do it. Okay. Yeah, this is kind of how I remembered it last time I tried this, was that you just get like an insane amount of bugging out all the time. So there's also some cool shit though, like that. That's pretty cool. The prices shot up due to the chip shortage. Yeah, 100 is pretty cheap. Wait, really? That's crazy. Yeah, this one's cool. That's pretty sick, Rob. Yo, Rob. What you gotta say about this one? You ain't seen a ball like this since fucking Doc Ock in Spider-Man 2, bro. That's a ball of energy. You know that scene where he like puts his hands to it and he's like, I now harness the, you know, the world or whatever. This is really cool. Thanks. See, that's all I ever wanted. Oh, ball. Atom bomb. Yeah, it's, see, that when you have the growth function like this though, it gets glitchy really quickly. So I don't think that it's doable long term. It's just not doable. There are some cool things with it though, but yeah, that's why we have it like this, but yeah. People would buy them because there was nothing else. That's crazy. That's crazy. I mean, that's just the way it is though. That is the way it is. Yeah, I wonder what I even have differently, like, from getting it to work now. Like, I mean, I don't know. Like, I had this at 1, or it would be. Wait, hold on. Yeah, 1 would just give you that. Yeah, so 1 is off completely. 1 would be immediate. Yeah, so 1 is off. Which we already had this at 1 and then it didn't do anything. Well, we tried out a lot of ideas today. I don't really know if any of them I'm really happy with, to be honest, but we did try them, at least. We did try them. I did say that I would move them onto the UI, which we didn't do because that was boring and I got kind of carried away. I hope that, okay, so this is what I hope. I hope that the bell lookup that we did earlier isn't the problem. That would actually really suck. Wait a second. Why didn't I fucking think about that? Huh? Why didn't I fucking think about that? Wait, like, am I fucking stupid? Am I stupid? Like, really? It didn't occur to me. That didn't occur to me. The fuck is wrong with me? Wait, what? That didn't occur to me. Okay. Like, I think I forgot what I implemented today, which is interesting. Did not occur to me. Mud Simulator is crazy. Bro, he's just chatting shit, bro. It's classic behavior, classic Rob behavior. The craziest thing is that this looks like it's biased in a certain direction. Yeah, it is. Like, look at this. You see that shit? It's just biased in that direction right now. Which is very interesting. That is cool. I mean, it's just, yeah, it's cool, but it's like not right. It's all going in the same direction, bro. Yeah, well, at this point I'm not even using velocity. I'm just literally trying to get it to not be biased and to not die out. But it's kind of hard at this point. Technically our DD should be 1, but I pushed it higher just to see what would happen, but probably not the best idea. Our DD is 1 because that's the radius of our thing. That's pretty cool, but yeah. Yeah, the problem is when you have a sigma that's really close to your DD, then you have, like, you know, problems getting anything because the clamping range is so small. Even if this I have a sigma that's very close to my... Yeah. Yeah, you have problems when you get a sigma that's very close to your D. You do get problems. Oh man, like I would love it for it to just like work, but I just don't know. Yeah, well, whatever. That is just what it is. The only thing we do differently than them, right, is that they do this. They do this. And then they clamp it between... Actually, yeah, so we should try this, their method again, because the last time we tried it, we kind of just like gave up on it real quick, but... It may work better than what we're doing, so... Because that's technically how it's supposed to be calculated. Yeah, this is the exact problem that I had when I implemented it last time. Was you just don't get a lot of action, you know? More action, yeah, that's what I'm saying. Like, you know, like if you literally just do this and then say, you know, in src equals destination, you literally just do that then this is going to be like what we had before, right? Yeah. Yeah. It is just kind of fun to fuck around with it. Like, I don't really, like, you know, I'm not actually, like, that pissed off about it. So what's happening right now with the math, that's what we're mad about, is that basically we're adding too much mass, right? So we're adding way too much mass into the surrounding cells, so that's why everything keeps dying, because there's too much mass. And so it's really, really impossible for us to get rid of it, though, without dropping the sigma to this. We could probably, like, you could probably get away with it at, like, 3, maybe? It is all biased towards positive right now, I know that, but it is doing things, it's just not, it's not, like, extremely interesting. I do kind of regret doing that, though. I think that, honestly, we were correct about this. That's what biases it towards positive, is that, at least I'm pretty sure that that's what it is. Yeah, sigma of 0.5 just really kills everything, doesn't it? It really does. Or 0.4. So I think the key is like a really low sigma when you have a low DD like ours. Sigma of 0.5 to 4 is a beta? Is that the rule? I didn't know that there was requirements to be a sigma. I thought that anybody could be a sigma. Wait, really? Are you gatekeeping being a sigma? No. No, right? No, right? Okay, I'm actually going to clamp this still, but I'm just going to get rid of this. And just go sigma minus, yeah. Just do this, and then we'll keep the clamping. Because the clamping is obviously doing things for us. It's keeping us from getting too much mass. Too much mass. Okay, we're still getting too much mass. Sigmas do protect us from gaining mass. It's just not doing its job. It's not doing its job right now. Alright, a sigma of this low must mean that something is really not working. That's kind of ridiculous, to be honest, that try to turn it to 2D normalization, but like this is ridiculous. Yeah, it might be this. It might be that we need to... Yeah, it might be that we need to just like switch back to what I had before, I guess. I don't know. But this like biases us towards positive, 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 which is what we were annoyed at before. This is what I struggled with before when I implemented this, was that everything like floated to positive, positive, positive. So I don't know. I think it honestly it has to do with this, the way they do their like centering it in the middle of the voxels. I don't think that it's necessary at all for us to be doing that. It's just not necessary. It just biases things way too much. So there's really no need. That's biased towards positive, positive. If you look at it. Bro, like, how fucking crazy in the head do I have to be to, like, just sit here and fucking watch balls all day? Like, you gotta really... It really makes you think, bro. It really makes you think. It really makes one think. Okay, now we're just we've like we're just like got like a lot of balls that go up, you know, and get bigger. That's all we got now. Oh no. Okay, you know what? I think we've learned our lesson. This is pretty much exactly what it's supposed to be, right? So you roll, you get the source. Yeah. That's exactly what we got going on here. That's exactly what we got going on. Get the source. Do this, you know. Yep. Absolutely. Right there with you. Yeah, and we're using the destination. Absolutely. Yeah, I just think that this isn't like the more interesting way to do it, to be honest. We could try this, just using the velocity instead of the mu, and see if that does anything interesting. No, I don't think so. Oh, you know what? I'm just gonna go back to what we had earlier, to be honest. Like, this is just not what I really signed up for. Yeah. Well, you know what? It was a learning experience, I guess. Yeah. I'm just like reading out some of the variable names in my head, and it's just like very funny to me. Like the mummy and the scissor. Yeah, it's really funny. Um, yeah. Yeah, that would be a crazy party. A Sigma DD mummy party. That's a crazy party. That's a crazy lineup, bro. Yeah, you know what? You know what? We worked really hard to get it implemented, but I just feel like we gotta, yeah. Fuck it, bro. Ah, the Gaussian kernel was so cool, man. That was good times. Bye bye. Okay, that's as far as it goes back, because this is, if we remember correctly, this is where my computer crashed. Gen Alpha developers on the job. This is what they do. They just control Z the entire code base. Is that what they do? Yeah, I love control Zing the entire code base. It's exactly what I like to do all the time. Yeah, so back to what we were doing back here. Instead of using the pause array minus this, wait, hold on a second. We use the pause array of the MIDX minus the, wait, hold on a second. Hold on. No, that's completely right. That's completely right. Because this is the V. This is the V. This is the V. Yeah, this is the V times the time step. Absolutely. Yeah, yeah, yeah. Yeah, yeah, I'm not crazy. I'm not crazy. Oh, cool background music. Yeah, 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 yeah. I got you, Rob. I'm right there with you. Yeah, yeah. I got you, bro. I gotta use my mind to tap into the program. Yeah, yeah, yeah. I'm right there with you. Ah, Rob. Oh, Rob. You don't want to fuck with a man who's got nothing to lose. uh, was I adding into... Was I adding straight... I was adding straight into MIDX, right? I think I was. I think that's what I was doing, right? X0... Yeah, yeah, it was all MIDX, yeah. Yeah, you don't want to... Yeah, you don't want to mess around with a Sigma male like me. Let me tell you. Things could get messy. The walls will be covered. If you look at it a certain way, you'll find that it's biased in a certain direction. Rob, you ain't leaving shit. You ain't leaving nothing but the toilet seat up, bro. That's a good line. That was a good one. Fundamentally, it's flawed. Fundamentally, what we're doing here is flawed. Fundamentally, what we're doing here is flawed. And I don't think that clamping it is going to solve anything. I think it's just fundamentally flawed. I think, like, this idea just doesn't work in a particle system. What I'm trying to make happen. I thought this stream was lagging, but I'm standing really still. Yeah, it's just all, it eventually just all, you know, gets into the same order. Like, everything gets into the same exact order. Clamping just, you know, gets us there slower, I guess. Sigma masters don't move. We can stand perfectly still. You gotta move when a car is about to hit you. You know what I mean? You gotta move when a car is about to hit you. I feel like even if you're a Sigma, that just still is like a bad thing. Clamping? Yeah, exactly. Well, it's not like normalizing, but it is clamping to, you know, be between two ranges, yeah. Clamping isn't going to solve anything though, because the values just always end up going to the same place. Well, they don't always end up going to the same place. Basically what's happening is it's a butterfly effect, right? So when one particle wants to go here, it ends up affecting everything else, right? And everything else starts going in a wave, right? And then it just can't break out of that. You know? Oh, yeah? He goes to the hospital? Yeah, that sounds like very Sigma. Going to the hospital is the most Sigma thing I've ever seen, to be honest. Yeah, so this velocity idea might not be working. Yeah, so what they do is what we just did, which is like basically they just like put a kernel around yourself, and then they just basically spread out the difference, right? But we're trying to do it the other way around because I thought that would be more interesting, but it isn't really working, to be honest. Dude is Windows XP. I am Windows XP. Yeah, bro. Yeah. If it's really close, yeah, so it needs to be really far. And it pretty much is always far, maybe? Yeah, let's actually just like literally see what the values are like. For the difference between them. A real alpha? Yeah, I mean, this is like the least alpha stream I've ever done, actually. This is like, you know, this is cursed. This is awful. Okay. I'm glad that you're all finding amusement in this, because I'm not. Oh. Yeah, I'm just not really amused. You can't put Rob in timeout. He's a Sigma. It's unfortunate. We've all tried to put him in the timeout. He's a Sigma. He's legitimately like a Sigma male, man. Like, different breed. Okay, why are all these mu's? Okay, this one's greater than 1. This one's 1. Wait. Okay, no, we're stepping across. We're stepping across. We're stepping across. No doubt, no doubt, no doubt. No doubt, no doubt, no doubt. No doubt, no doubt, no doubt. You know what I'm realizing, though, is that this doesn't actually wrap. Oh, shit. Hold on a second. Hold on. Lock in. Lock in. Lock in. Hold on. That doesn't wrap. That doesn't wrap like Spotify wrapped. Hold on. Hold on. Lock in. This is what I had here. Okay, I'm plagiarizing it. Hold on. Lock it, lock it. Lock in. Wait, hold on. No. Okay, it's incredibly laggy. But we're locked in. We're locked in. We're locked in. Is it biased in a certain direction? It definitely is. No. It's still biased. It's still biased, yeah. What am I building? I'm working on a 3D application for cool looking shit. That's all. Taco Bell After Effects. Okay. Alright. Did you use CGLM or any other math library? Oh, no, not really. I used my own kind of math library. Yeah, no, I didn't use GLM. Giant cube of triangles. Yeah, I've been told that I'm a giant cube of triangles sometimes. I've been told that a few times. Why is it so fucking laggy? What did I do? Like what? Like what did I do? I mean, all of this shit is here, but it's not actually getting executed because it doesn't do anything. So I'm fairly sure that it doesn't matter. This surely can't be the expensive operation. I think I may need to give the computer a quick reboot to keep it 100 with you. Like, I don't know what's going on here. What? That's a really long frame time, bro. Was it really from clamping this? That just can't be. That just can't be. It has to be. It has to be. It absolutely has to be. I mean, yeah, today just ain't the day, dude. Like, what the fuck is even happening today? Is it really the clamp? Like, do not tell Rob that he isn't a Sigma. Do not. You don't want to mess with that guy. I've seen Rob when he's angry. Reminds me of the old 2000s graphics to dance music. Yeah. Yeah, that's totally it. Yeah, I think I fucked something up bad. Yeah, I'm just gonna give it a little bit of a reboot, you know? Yeah, I think that I have to at this point. It's, I'll give it the old, you know. Hey, but it takes one to know one, you know, the whole Sigma thing? Dude, I feel like I've just been like, you know, just like sitting here for like 8 hours, just like doing random shit. I've not done anything, so. Takes a beta to become a Sigma? I wish I was a Sigma. So true. Oh shit. Lock in. Yeah, my computer might be a risk. Okay, you might be a risk if you come near me. Because I'm a Sigma. Okay, so if we suddenly... Oh. Wait a second. I was in debug mode, bro. I was in... Oh. Oh, bro. I'm tilted. I'm so fucking mad. Oh, dude. Dude, that's not right. That's just not right, bro. It's like the third time I've had to write this line of code. Maybe more. Oh, man. Why did nobody fucking tell me that? That's not the first time that that's happened. But in my defense, I'm writing the code that's right underneath me. I'm writing the code that was literally right underneath me. Okay. Okay, test it out. Yeah, it's biased. Yeah, I don't know. I think to be honest, like I think this isn't going to work, but I also think, yeah, I don't know. I think like this idea, right? It makes sense, but it doesn't work like I'm trying to make it work. Like we can't just like straight up add it into this. We can't just add it into this. And so you want to like add it along the ray, right? But it's like not that simple. So we've tried to make this work like so many different ways today. Like seriously, like, you know, we basically like did this in a loop and then tried to like, you know, do it so many different ways, but if you accumulate too much mass near yourself, especially because of the growth function, then you just die out immediately and you don't get anything interesting. But if you try to use this velocity, then you end up, you know, biasing everything. So it's like really difficult to figure out how to make it work. I thought I had it working, but it was really just a bug. So nothing new there, but like, yeah, it sucks. It sucks. It sucks. It sucks. Yeah. The way they do it, right, is that they just loop over it, right? And then they accumulate into it what's around it. But doing that for us is just too slow, and I think that we can find a better way to do it. We can find a better way to do it than this. Like, they do it this way, and then they just like loop through, and then through each one, and do this. But I mean, they use the mu at the new location and compare it against the SRC position. To see how far it is from this. Maybe I should look at the source code. Maybe that'll be illuminating to me again if I take a look at this. DPMU plus the sigma, yeah. Yeah, and this SN is what's up here. Is this. Or this. Depending on what we have. Like right now it's just this. Yeah. So that is correct. That is 100% the formula. So I'm absolutely correct on that. Look at the code. It's commented everywhere. This project has only made it this far by pure luck. Rob, you're a very fun person to be around. Have you ever heard that before? Like, Uh, like, I mean, I'm just like saying, you know, just being honest here. Oh, what's up, Isabel? I thought you started that by saying you should know that I'm working on collision stuff. I didn't know, but now I do. You're a wage slave? Yo, that's hey, you know, you should be proud. If you were here right now, you'd already be punching me in the face. You know me so well, Rob. You know me so well. I'm just moving the variables around to pretend. Maybe it's gonna work. It's gonna work. It's gonna work. It's gonna work someday, and then it's gonna be great. Yeah, we're just, yeah, you know all about it. We've already done this, you know, a billion times. Gonna do the grid index. That's not a grid index. You already know. That's not a grid index. What the fuck is the function called? Calc pause. I called it calc pause. I called it calc pause because that's what it does. It takes in the X and the Y and the Z, and it doesn't bounds check it because fuck that. Oh man. Rob, can you help me out here? You seem like a guy who could help me out today. Oh man. Okay, we got the SRC. Okay, so let's just keep it really fucking simple here. Okay, we're keeping it really fucking simple this time. And we're not gonna do any of that bullshit, any of that Gaussian bullshit. No. We're not gonna do any of that. We're not gonna do any of that this time. What we're gonna do instead is we're literally just gonna add it in. Like we're not doing any of that. We're not doing any of that. We're gonna go back to this, okay? Okay, we're gonna fucking comment all of this shit out. It does not exist. We're going back to the basics, man. Okay? We're just gonna go in a circle around it. We're gonna accumulate the mu. Okay? No big deal. No big deal. No big deal. Okay? Okay. Did I just... No, I think I copied the code into the wrong place and then... Whatever. Okay. Think it did get restart? Yeah, I just like Control Z the entire thing. You missed me literally like Control Z everything. So, yeah, it's not doing too well. It's basically, so the problem is that it's not a bug. It's just like the concept I had, which was aligning the velocity with the current frame velocity and then using that to push our momentum forward, ends up just biasing the entire simulation in one direction, and it looks like shit. So it's not really a bug, as it's really just like my idea was just bad, and now we're like trying to cope with like, oh, it's not that bad, but yeah, it is really that bad. Like, you know. That's the worst type of thing, though. You know what I mean? Like when you have an idea, and then it doesn't work out. DDA. Yeah, exactly. Yeah, it's just you can't bug fix being stupid, unfortunately. You can't. Okay, we might have to move the sigma. I think that there's just not there's too much normalization going on. That's what I was trying to say. Very close to having your volume object. That's awesome. That sounds pretty sigma of you. Where's the... Yeah. Yeah, I mean, I think that, to be honest... Yeah, I feel like, to be honest, both methods are just like really shitty of distributing the mass like it is. Alright, peace out. Good luck. Yeah, peace out. Peace out, good luck on all that. Share whatever it looks like when you get done with it. I'm supposed to be using the SRC. I am using the SRC. I am. Loan securities. Oh my god. Man, I thought you were joking about the whole wage slave thing. I mean, like, not joking, but I mean, I thought that, you know, I didn't expect it to be that bad. Jesus. Yeah, it's just balls that are getting bigger. It's really not that exciting anymore. Oh man. It's just because there's too much mass. There's just too much mass so that it expands like that instead of doing anything interesting. That's the problem, is it just like expands. What am I making? Just like a 3D graphics thing on Windows XP. Yeah, I just didn't expect that it was like, you know, loan stuff. Man, that sucks. That really sucks. Oh man. Yeah, I don't understand. Like, this is what Flow Lenny is supposed to look like. It's supposed to look kind of boring like that, but like, I don't know. I feel like we probably should be trying to do better than that, to be honest. I think that this is like the problem with this normalization that they have versus what we have. The problem with what we have is that biases things, you know, and they normalize it properly, and ours just biases them. And also it doesn't clamp it, and so if we do any like fancy calculations with the velocity, like we were doing earlier with aligning it with the mu, like we were doing the vector dotting, then things just go crazy, you know. The more correct the math is, the more boring it gets, which is like the most annoying thing. Yeah, I think the hyperparams are just like hard to get it living right now, so that probably has something to do with it. But yeah. We're not even doing anything with the velocity now, so it really, I don't think it has anything to do with that. What did I set the porter to? Taurus? I feel like that should be doable with our current parameters. It's just kind of like, you know, kind of wondering. Something we did earlier. Yeah. The normalization is making it die out really fast, which is fucking annoying. This is the old code. Yeah, I mean, what's exactly different than this and this? Really nothing. Except, I mean, we aren't explicitly using pause array, but we basically are. We're using destination. Yeah, I just did this thing where we're just adding straight into the source from the destination for like the same thing, just to test if things are working properly still, but yeah. I did go back to having the this lookup table, which, you know, I just said could be a problem. Like, we never really verified if it's really great or not, but yeah. So we should really just be trying it without it. So that's also a thing. And our mu is not yeah, it is plus 0.5, so it is still that. So that should still be fine. Yeah, I wonder why it's so hard to get anything happening today. I think I probably changed something and then forgot or something, and then I'll remember later. Okay, no, yeah, with the lower DD we seem to be getting more action. Technically we have a DD of 0 because it's basically the radius of our roll, and so we don't have a roll currently because I just deleted it, but yeah. Okay, so all hope is not completely lost with this. Yeah, I think just set it to this in 0.9. Like, this is like kind of what we had it at originally, and then from here do the DD thing. Again, now that our hyperparameters are kind of figured out, now just do the DD thing. Now, I doubt that it's going to work, but, you know. The important thing is you want the parameters to be good before you do something like that, because it's inevitably going to, you know, mess things up. That's what I had before, and then I like we had to restart because I messed with the parameters, and then everything got out of whack. So okay, we are getting action. Okay, we are getting epilepsy. Yeah, it is really, really laggy with all of the stuff that we have going on right now. I mean, it's mainly the roll at the end of the day. Oh, we got a seg fault from the kernels. Because I pushed some thing out of bounds. I don't have bounds checking on any of the parameters stuff, so yeah. So I mean, but that works though. It works though. It's just like really, I think the parameters are just super touchy. Like I think you just need like really low normalization on it. Okay. That's cool. I think also having the no Sobel border really does help. Like without it, you just kind of can't get any form going. Yeah, it's just really hard with a wrapping border to get anything that isn't just noise. And maybe they could be solved by having a higher radius, but we just can't do it. We just will literally never be able to do it on this computer. Yeah. I think the problem is honestly this border. Like this border just, you can't do anything with it. Everything just dies out immediately. So yeah, I think I'm going to try aligning the vector with the velocity again, and then I guess give it a break. I don't know. It is kind of stupid that I have to write that code again because I did delete it, but yeah, I do have to if I want to try that again. So I'm not tired of the project. I'm just like It's not the project, dude. It's just I don't know what to do. You know what I mean? Like, I have it at a state where it's really cool, right? And it's like anything I do just makes it less cool. You know what I mean? I hate when projects like get to a point like that. Like it just really pisses me off, you know? Because it's like, I don't know. I just don't know what to do. I'll figure it out too. I'll figure it out, but it'll take like a week of me like doing like days like this, you know? This is how like the past few days have been too. That's just you know, just here, you know? Trying shit out. Yeah, so we want to get this once again. Yeah, so you want to do this and then get it between the range of this. The algorithm and the code is completely unclear. Yeah, I mean, so it's like a part of other people's algorithms and my own type of like experimentation, right? So it's not like it's kind of like I'm trying to, you know, I'm trying to not do mass conservation in, you know, it wants me to do, you know, to conserve mass, and I'm telling it explicitly not to conserve mass, and it's like not working, right? It's like extremely not working. I think first of all we're lagging a lot, but also, oh yeah, so I'm supposed to go 0.5 f, yeah. Yeah, I think it's just gonna lag too much, so there's no point in even doing it. Oh, yeah. The idea of what I'm doing is interesting. Yeah, I mean it is Windows XP, but yeah. It is really, it makes us so much slower to do that yeah, it's just not worth it. But it isn't a really good idea of like, basically we're checking how aligned our current vector is with our, you know, moving average of our velocity, but it's not gonna work, I think. It just becomes really hard to traverse the space when, you know, when we get to have shit like this, like it just does get to be, so. And yeah, our alpha is, you know, still experimental, but yeah, I like, yeah, it's just. I think I'll figure it out eventually, but it's like, it's not easy, man. Yeah. I'm kind of burnt out for the day, though, to be honest. Like, I don't know. It is true, though, you know, the more correct the math gets, the less interesting it feels, you know, and it's like, you know, it does like look way more interesting without a DD at all. But the problem without a DD is that you don't have any actual velocity anymore. And so if I want to make the velocity work, then I have to do the roll. And, you know, it's like a catch-22 in that sense. So, I don't really know. What I was going to do is I was going to, like, go here and then, like, literally change the amount of kernels that we get to, like, you know, just, like, 4 or something. Maybe it'll be, like, simpler for it to... But, yeah. I feel like, I mean, I didn't get any progress done today, which is like so annoying. I guess it's just like when we get like the math more complicated like this and stuff, like maybe it's like that the space just gets a lot more sparse, I guess, you know, so yeah, that's all right. It's all right. Welcome back. Not much has changed. I'm kind of like burnt out and thinking that, you know, I might be done, but yeah, I mean, I didn't get anything done today, which really annoys me, to be honest. It always sucks when the idea you have in your mind is just not implementable. You know? If I use this moving average for the velocity, then to actually influence the position of things, then it's just going to bias it into a certain direction, you know? So, I'm not really sure. Something interesting we could do is that, like, we could use it for alpha. We could use velocity for alpha. But yeah, the space just becomes so sparse like this. No. You know? Which is unfortunate. I think it's like kind of pretty much like what Lenia is kind of about at some point, but yeah, it is kind of annoying. I think it's directly because of the way we're doing our growth that we do it beforehand. I think I'm gonna use the velocity for alpha. I'm gonna watch my game engine building videos. Is this project easier? Oh yeah, way easier. Like, this is a joke. I mean, this project doesn't have a clear goal, right? You know, so it's not like it's got nothing to do with with what the engine is like. That like had like a clear, like, okay, I'm gonna do this next, and I'm gonna do this next, and I'm gonna do this next, you know. This doesn't have that. It's just kind of like me dicking around and trying to see what I can do, right? You know, like with my what I know about, like, you know, math and stuff, and like seeing, can I make something really fucking cool, or is it going to suck? You know, it's basically that. Yeah. So we're basically just gonna do this, and then just take the square root, and then call it a day. Where did my... I have no clue about the scale of this, though, is the problem. This V is not going to be in the scale of 0 to 1. Not at all. That's a good question. I mean, yeah, never mind. You can't get it from 0 to 1. Making a function that's fungible. That sounds like fun. No, yeah. I mean, this project is easy, because if I wanted it to be over, then I would just say, okay, I'm done, you know, and I'd just like move on to something else, which eventually I will do. But it's like, you know, I know that it can be cooler. I know that I can do it better. I just need to kind of like sit here and like think about it for long enough, you know, before I fucking figure out how to do it. Like, you know, because it's not through this. There's some other way that I can do this. I need a way to like actually influence the position of things without throwing everything off. Maybe velocity isn't the best way to be going about this, since it isn't a particle simulation, you know? It isn't a particle simulation. So, I mean, velocity might not even be the thing that we should be looking at. I mean, it was a neat idea. The idea was like for like high velocity areas to, I don't know, push them along, but maybe it's just not a good idea. I don't know. Yeah, I mean, the thing is, they don't even, I don't think they even apply, or maybe they do. No, yeah, they get the growth, but then they don't apply it. They do the Sobel just like I do. with it. And then they do the alpha. And then get F. And then they do that. Yeah, so they do it exactly like I do it. I think in 3D it just doesn't work too well, to be honest. I think it's just hard to get it to work in 3D. That's another part of like contention for me. So like, you know. Yeah, it does really look like a modern engine. Yeah, pathfinding is crazy, yeah. Pathfinding is hard because of like jumping and obstacles and shit like that. Like it's really not easy in cases like that, you know. It's not easy at all. Yeah, that sounds cool. I don't know what Proteus is. Yeah. Yeah, I mean, whatever, dude. I was going to like hook up these parameters into the UI or whatever, but it's like at this point it's like whatever. I don't know. PCB design and circuit simulator software. That's cool. Yeah, that sounds awesome. Yeah. That does sound like a lot of fun. Yeah, so I was going to do this and that's why I left this here. So what's the pattern here again? It's off equals border. Yeah. So then and then we do the thing. Okay. So yeah, so off equals border, and this is going to be sigma, I guess. Yeah, so it's just going to be like this, the exact same thing as this. So let's just do this. It's like the exact same thing for sigma. And the data will be sigma, no, off table dot sigma. The issue with this is that it actually affects the MA. Alright, peace out, Rob. I probably won't be. I'm probably gonna, you know, just like wrap it up soon. But yeah. Yeah, I mean, we can't actually call decrement here because, or actually we can, because we have a secondary callback, don't we? Yeah, so this is gonna it's gonna call the initialization function for an init offset table. Yeah. Oh, the problem is that this takes in this when it really shouldn't. Yeah, then I have to do this code. Really, you could just literally comment all of this out because we don't even use any of that. And then just like literally move this outside of the function, and then this just literally becomes dd minus sigma equals ma, and that's literally it. So that's what we should do. So this just doesn't take anything inside, and that's it. That's the whole function. So many cool ideas that I have all the time. Yeah, that's probably what I should do, is just write them down, you know. Okay, let's see if this works. What is an offset? What is a height plus offset? Whatever. Make button. Void to void. From void pointer. What? What is the... God fucking damn it. You hate to see it, but I don't care, is the funny thing. So... yeah, that's so crazy, but... oh wait, hold on a second. Is that the wrong... wait, that's the wrong file, isn't it? Yeah, it is. God damn it. Whatever. We're about to do this anyway, so... that is what it is. Yeah, just get rid of this and rid of the other stuff. Okay. So that's that. Now it has to take in a button so that I can satisfy the function signature of the other thing. So there you go. It has a button now. Undeclared identifier. Undeclared identifier. What? Oh. Yeah, we gotta put in a null there. Visual Studio 97. Yeah, we gotta go back. We gotta go back. What, like... oh. Okay. I put it in the wrong file again. I gotta close that buffer, man. I gotta close that buffer, man. What now? Oh. Okay. Can we get something so that we can test this out? Please? 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 Give me something. Give me something. I'm fishing and I'm getting nothing back. Okay, we got something. We got some little floating amoeba life forms now, which is plenty enough for me. And we're gonna raise the sigma. Okay, we're gonna bring the sigma down. Okay, or bring the sigma up. Okay. Okay, sigma at 0.9 seems kind of dope. Seems kind of dope, to be honest. Okay, for a second it seemed kind of dope, but now it's not. Okay, well. Okay, we can go and make the next button now. We can go and make the next button now. Sigma, 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 sigma. Okay, I had enough. Okay, well that works. So we can make the next button now. I probably am going to leave soon. I know I didn't do anything today. I feel bad about it, but yeah. We don't have to redraw now. I'm just wondering why the value doesn't change when it's oh, we don't actually have the because we don't actually put the sigma in there. I just didn't even put the sigma in there. So that's my bad. And so I guess we can copy the channels thing. Kind of wish that there was, oh, time step is good. Okay, time step is good. So we can just copy that next to it and then just put the DD here. I don't know why they're not globals. Yeah, it's whatever. Bool. What? What? Placeholder redefinition. Ah. Yeah, that one makes sense. That one makes sense. Okay, so our DD is here. I have no clue how to test if that works. We can just test to see if something gets changed. When we have something on the screen, which we do now. Does a DD do anything? I feel like no. I mean, it should technically change the range. Okay. Oh, it's not doing anything because I forgot to... Because I forgot to do this. Init offset table. What else did I want to do here? I guess I wanted to do the porter buttons, I guess. And then I wanted to do all of this, the GTA, STA, and then the velocity. But the velocity, like at this point, who knows if I'm even going to keep the velocity, so. But, you know. But it's fairly simple to do, to make new buttons with the menu system that I have, so I might as well just do it while I'm here. So this is going to be GTA, which is grid temporal averaging, and then this is the STA, which is the sum temporal averaging. And so this is just going to go to that. Very simple. And then after that we have two more buttons to do. And it's going to be for the V beta and the for the V damp. Okay. Also, this is supposed to be also GTA. STA. I called it that. Okay. Okay. Yeah, I feel like I should have just done this at the beginning, because this would have helped us instead of like just rage compiling over and over again. We could have just like you know, used our UI to do it, which, you know, would have been real neat, I guess, to test out how things are affecting things. Dude, it seems like having a high sigma is actually a good thing. Yeah, it doesn't appear to do anything. Oh, that's cool. Oh, sick. Huh. Okay, that's pretty cool. Yeah, that was pretty cool. I have a feeling that the potential is here. We just have to kind of like work for it. Yeah. Yeah, I have to... I'm gonna play around with it more, but... It is really hard to get it alive. I also don't think that the DD does anything when it comes to, you know, recomputing the MA. I just don't think that that does anything. Alright, I will, I might be back tomorrow. I've got to really, like, think hard tonight, I think, about, like, yeah. Oh, my sister just got home. Yeah, I've got to think hard tonight about, like, what I'm doing. Like, with this, like, this is seriously, like, annoying me that, there's so much potential here, and, like... Yeah. Yeah, there's a lot of potential here. It's just like, you know, really difficult to Yeah. All right, I will see you guys maybe tomorrow. Yeah, like I said, I gotta kind of think about what I'm doing. I don't think that this velocity idea is actually going to work because I think it just fundamentally is flawed. Like, it's not a particle simulation, so that the moving average of a velocity for a cell doesn't actually mean anything. So it like seems neat in your mind, right? But it just doesn't really make sense. Yeah. And the problem is with it in its current state, even though the math is correct, it's just literally noise, you know? So there's also that. So yeah. All right. Well, I'll see you guys later. Yeah, I get carried away playing with it, you know. Yeah, I'm surprised that the MA doesn't do anything. Like the DDMA just doesn't do anything. To the F. I wonder what that means. Yeah. Yeah, I think it's got to do something with like magnetism, like having certain positions that are attractors and detractors. I think something like that is probably what I'm gonna do. I think that that's the way to implement what my idea was with the moving average of the velocity, is to create positions that are attracting rather than doing this velocity that everything ends up getting pushed in one direction. We just basically set static positions that are attracting and pushing away from it. I think that might be an interesting way of going about it, but yeah, I think that's what I'm gonna do. All right, I will let you guys know if there's any updates or I figure anything out here.